环境工程研究所马鸿文马老师马教授，掌声欢迎 Professor Ma from NTU to talk about ecological design and business models of sustainable products. 马老师好。
是要说中文还是？Okay, good afternoon, ladies and gentlemen. Yeah, it is very pleased for me to be moderator for this session. I'm Hung-Wen Ma from National Taiwan University. This session is about sustainable product design, provision, and also business strategies. So in order for us to move towards circular economy, the sustainability of the products is in the center of this transformation path. So we are happy that we have 5 distinguished experts in this session. I'm going to briefly introduce them. We have 5 speakers. The first one is Mr. Peter Calliafas, and the second is Mr. Boris Boehme, and also Mr. Arthur Huang, and Miss Vivian Wu, and Miss Vivian Tai. Okay. Peter is actually an advisor for a lot of companies, and also provide advice for government, especially regarding business strategies and technologies. And he's going to share with about business strategy today. And the second speaker is Mr. Boris Boehme. He is the director of ICT Technical Regulation in Federal Ministry of Economic Affairs and Climate Action. All right. He is also working on a very important task, which is standardization of circular economy roadmap, and particularly on digital product process. So digital product process will be the topic he's going to present today. The third speaker is Mr. Arthur Huang. Arthur is the CEO and founder of Miniwiz. So he is actually an entrepreneur and innovator. This company is actually focused on upcycling by turning waste into building solutions. So today he's going to share with us about the experience of Miniwiz on upcycling. Then the fourth speaker, Miss Vivian Wu. Okay, she is the director of the Industry Foresight section at Taiwan Design Research Institute. Okay, so Vivian is actually the designer. She's going to present the principle on sustainable design today. And finally, we have Vivian Tai. Vivian Tai is the lead of global product sustainability strategy at Dell Corporation. And she's going to talk about ESG, the experience of Dell Corporation. Okay, so let's welcome our speakers. Yeah, thank you.
Good afternoon, everyone. Can everybody hear me all right?
Yes, sir.
So thanks to Professor Ma, who I've known for many years, for that kind introduction. So this afternoon, I'm going to take you slightly left field on the circular economy, so you can actually see the difference on the various models that I've actually incorporated. So I'm going to cover a number of areas. I'm going to spend a bit of time on some of the key ones and canter through the others. But the key thing here is the circular economy model is not a one standard model. It applies to various businesses, various sectors in its own right. We all know the difference between a linear economy and a circular economy, but the first point I'd like to make is if resources become waste, we failed. There is absolutely no point in trying to mine materials from waste because we've actually failed when it gets to that point from a circular economy model. So that's the circular economy model in a nutshell. And when I get to the end of the slide, I'll show you the principles of a circular economy model that is half a century old and worked very, very well indeed. This is a key facet for government. If businesses are going to invest hundreds of millions of pounds in a new model, they need to have policy certainty. And they can't just have 5-year horizons with policies changing. So the challenge for government is for political parties to come together, agree a common policy agenda, and depending on who gets elected, they stick to that policy agenda because it's a common purpose between them. We need to make sure regulation actually fits, so you can have regulation for waste and you can have regulation for reverse logistics. Both are not the same, so you can have light touch for reverse logistics and something more fundamental for waste. Now this is an interesting one, and I shall try and be politically correct on this. If we have a look at plastics, for example, there's 400 million tonnes of plastic produced each year, and we haven't got the capacity to deal with it. So we've got a net linear economy model. Plastic can't be recycled forever. It's not possible. So all recycled plastic will become waste plastic initially. So the question here is, if products have no circular economy model, should they actually be banned? Likewise, if you have two products put on the market and one actually has a climate change and a sustainability benefit and the other one doesn't, they're taxed the same, the products is taxed the same. So should government bring in a taxation policy that differentiates between the two? So you could look at corporation tax, for example, being reduced for companies that do the right thing and being increased for companies that do not. And this is another key one for government. They need to take the first risk investment, either for proving a concept for businesses to adopt or to create the next circular economy entrepreneurs. And finally, UK milk deliveries in the 1970s is a classic circular economy model. I put in there the link. It's only 8 minutes long, and I suggest you have a look at it. They're well ahead of their time as well because they used an electric vehicle 50 years ago to deliver the milk. Here is an example of reverse logistics in operation, and I've chosen beer because I know it's a common delight for most of the audience itself. If we have a look at the bottom right, you can see steel coming from iron ore with the social and environmental impacts that creates. It then gets to a manufacturer, they make a steel keg out of it, and that gets delivered to the brewer, which is the customer, who fills it up with beer, takes it to the various business units, they use it in the pub, the steel keg comes back again in that green circle, circular economy model already working everywhere. So we don't need to overcomplicate this because there are case studies that work already. Having flown here from the UK on an Airbus 350, I thought it would be appropriate to give you the importance of the design philosophy in circular economy model. Again, the bits in white are the reference points if you want to work on these. Airbus has a common design philosophy for all its aircraft. The cockpits are the same, the units are the same, the engineering protocols are the same in every single Airbus. So when a pilot gets in a cockpit, they know where everything is. When an engineer gets into the hold, they know where everything is. If you want to change things, you can actually take the units out of this Airbus and stick them in another. They're completely interchangeable. So this is a design philosophy which Airbus has introduced. A, because it's easy to adopt, and B, it's cost saving for them. They don't have to reinvent the wheel. We talked about this morning about reuse and rental, and the rental market actually promotes a sustainable circular economy model. And if people questioned whether the reuse and rental market actually has potential, well, this is an example of a company that I'm aware of who set up a rental market for used phones, and they've recently secured 60 million euros of funding to take their business to the next stage based on reuse and rental. Now this is another one we've talked about at length this morning, but what I want to do is read the bottom to you first. Repair is recognised as having a high potential to maintain value within the economy, since repaired products have a higher value than the materials that are extracted through recycling. That's why I said if we get to the point of waste, we failed. So on the top left there, that's my laptop. And one of the keys actually broke, so it's there with sticky tape on the top. I approached the laptop manufacturer and said, could I have just a key, please, to replace it? And they said, no, you can't, you have to have a whole new keyboard. Right, that's why you've got the fail mark on the emoji. Right-hand side is mine again, toaster, well-known, reputable manufacturer. Phoned them up, said I've got a problem with it. They collected it, repaired it, and sent it back within a week. So 10 out of 10. Businesses are getting the repair markets. If you look at Apple, Apple used to have a business model that says we need to sell you a new phone each year, which costs them a fortune in development, in retail space. What they decided here is that we make it available for repair, we can actually make more money by selling you the spare parts. And that's why they went public, saying we'll actually introduce a self-repair service. And more importantly, you've got retailers now understanding that you can actually have used clothes from a well-known fashion brand and still make money from it. I want to spend a bit of time on this, on consumerism. We touched upon it this morning, but there is a classic saying that without customers, a business goes bust. So consumer demand has a huge influence in here. We've got a problem with consumers. On the one hand, their purchasing points are either based on price, they're either based on social image, or they're based on branded versus non-branded goods. So those are the decision points for consumers. They are aware in general terms about environmental impact, but it doesn't actually change their purchasing behaviour. So if you looked at the top right, that's the Atacama Desert in Chile. And the well-known fashion retailers, instead of allowing their goods to be put on the pirate market, they used to send them, like they are, to the Atacama Desert and just throw them in the desert. And that is fashion high-end in the desert. A lot of companies now have realised that you can actually make use of that, and Selfridges in London has now started a second-hand shopping enterprise. The most important thing here is greenwashing we talked about confuses consumers into doing the wrong thing. So what we need to try and do is bring the linkage between an environmental impact and a purchase decision together. Have a look at people who rush through duty-free. They buy goods and services from duty-free without one degree of consideration as to the environmental impact that's causing, because it's disconnected. So what we need to do is put environmental and the purchase decision together to get what I term as an environmental purchase plug-and-click. They understand the interlinkages between the two. This is a company I was involved in financing myself, so I know it very well indeed. What we've got here in terms of the actual investment drivers was one, sustainability. This company was right up the curve on sustainability agendas. The next thing we're looking at is hardwood provenance. There is a lot of debate about where hardwood comes from, and you get it certified as being sort of sustainable. It's not. Hardwood in the Amazon has been cut down at a rate of knots that you cannot believe. So the provenance is now questionable. And the final one is the European Union brought in a creosote ban, so the longevity of wooden railway sleepers was going to be shortened substantially. So what this company did was develop a composite plastic railway sleeper using HDPE as the principal ingredient, and in order to substitute wood as a in-track sleeper. And after about 5 years of development, they've now got this installed in Network Rail in London, in the London Underground, most of the European railways, and they've now invested in a second plant of manufacture in the USA. And what you can see at the bottom there is a railway track, and those sleepers are not hardwood, they're actually composite plastic railway sleepers. So if you look at this model, it's a classic circular economy model. You've extracted the plastic materials once, a bit like the beer keg, you put them into a sleeper, and they'll stay in track for about 50 years compared to a hardwood sleeper. And because climate change, sustainability and the circular economy are all part of the same coin, you can see at the bottom there is a huge saving in CO2 per track kilometre. So the circular economy is not difficult, it's just that we make it overly complex. And I think if we start to think about things differently, as these examples show, we can actually crack it. Thanks very much indeed. Shisha.
Shisha. Thank you very much.
Yeah, thank you. Good day, dear fellow campaigners for the circular economy. So I'm looking for... So the United Nations, the European Union and Germany are committed to the overarching political goal of greenhouse gas neutrality. So are we all. A circular economy can and must be the key to achieving zero emissions across the entire product range and will thus make a significant contribution to achieving this goal. The circular economy is implemented in the EU single market through action plans, and Germany is also developing a national action plan, and we have heard about it from Ms. Root from the European Commission today. On the right side you see the timeline from the Green Deal to the eco-design for sustainable products regulation. I will come back to this, and today I would like to use the example of the digital product passport to show you the efforts that the EU and Germany in particular are making to make the circular economy a reality. First, I will show you the EU's regulatory approach to defining the digital product passport, then the German standardization roadmap to show the status of standardization, then the example of the EU battery passport, and finally another application example from German industry to demonstrate the product carbon footprint along the supply chain. And I only want to show you highlights. So you will find QR codes at the bottom of the sites, and you can see the links. And this is only a definition. I hope that we are all clear about it. Digital Product Passport. The DPP is a key tool for building a circular economy. It is designed to provide information that facilitates or even enables the implementation of various R strategies, and you are all experts, so you know about the system. And now, this is what Ms. Root said in the morning. There's a new eco-design requirements for sustainable products regulation, and there's a definition in Chapter 3 of the digital product passport. You will find there's the general requirements, the technical design, the unique identifier, and the registry. And a circular economy is only possible by transferring data on the composition of products along the supply chain. This requires a digital product passport assigned to the product as a data carrier. Consumers, economic operators, as well as market surveillance and custom authorities can read the required information from the DPP via a unique identifier attached to the product. So you see here some information that's original from the European Commission, because I'm speaking for Germany, but we are a member of the European Commission, so this is our law that will come. Before I come to the German standardization roadmap for the circular economy, I would like to briefly explain the EU product regulation. This is necessary to understand the importance of standardization for the design of the DPP. I'm an expert in technical regulation, especially for the EU single market. In a nutshell, the European product regulation works as follows. There are 27 member states in the EU, and they adopt harmonized product regulations that apply equally in all member states. The legislator specifies protection targets in these regulations. I'm also responsible for toy regulation, so let me explain an example here. The legislator simply specifies that the toy must be safe. This is a protection target. This is done, for example, by setting chemical limits to that small children do not get poisoned by colors when they lick toys, for example. These limits are set by scientific advice. The European Commission then gives standardization mandates to the European standards organizations, which in turn create consensus-based industry standards. Manufacturers who apply these standards can use them to prove that their product complies with the product requirements of the EU single market. Private conformity assessment bodies can be involved in this process. These in turn are accredited by state. By affixing the CE mark, economic operators declare the conformity of their product with the legal requirements and can place their products on the EU single market. The state market surveillance authorities check the conformity of the products on a random basis. This is how the European quality infrastructure works. So it's and now we go a little bit deeper. It's about the standardization roadmap for circular economy. The aim of the standardization roadmap of the German standards organizations is to provide an overview of the status quo of standardization in the field of circular economy, to describe the requirements and challenges for the key topics, and to identify possible concrete needs for action for future standards and specifications. And there was a steering group coordinated the roadmap. I was a member of this steering group. The group brought together executives and experts from industry associations, civil society organizations, scientific and research institutions, and the public sector. And for a deep dive, I've linked you to the English version of the standardization roadmap with a QR code on the right side. Using the example of the digital EU battery passport, it will be explained how legal regulations can be implemented with DPP, thus enabling worldwide circularity of batteries. The EU battery regulation provides for the circularity of batteries. A digital product passport is absolutely necessary and mandatory here to ensure the availability of data along the product cycle. The battery passport is designed to meet the requirements of the upcoming EU battery regulation, which will be mandatory for all new batteries in vehicles, stationary storage facilities, and larger industrial batteries in Germany and Europe from 2026. The battery passport will gather all relevant information along the entire life cycle, from raw material sourcing to recycling. The Battery Pass project, funded by the German Ministry for Economic Affairs and Climate Action, is drafting substantive and technical standards for a battery passport along the value chain and applying these in a pilot project. The battery passport supports the sustainable circular management of traction batteries of electric vehicles by providing a digital infrastructure for the documentation and exchange of fundamental information and technical data. The battery passport is to include, in particular, data that comprehensively records the sustainability and responsibility of the supply chain. The Battery Consortium receives funding from the German Ministry, but considers itself responsible for the entire European and global battery supply chain and stakeholders. Battery Pass Consortium develops interoperable technical standards under the following principles. You see it here: top-down approach, consider ISO global standards first. technology independence, enable seamless adoption of results coming from technological progress. The global impact, support coexistence of standards by providing interoperability solutions. Modularity makes a standard stack suitable across sectors to entire DPP and ensure easy changeability. And support legislative process. I showed you the quality infrastructure. This is the system for it. And in practice, you see here can you see the benefits of all parties involved in the circular process for batteries. A lot of information, I know, but you have the QR code. So, and if you go a little deeper into the IT structure of a DPP, we see the complexity of a DPP system that not only has to meet all regulatory requirements, but also has to be manageable for all actors along the product cycle. You can dive deeper again here via the QR code on the side. The standard stack, you see here, provides a modular technical backbone to operate the battery passport on all levels. Users, governmental certification authorities, OEM suppliers. The design of the battery passport is a great challenge and at the same time a blueprint for future circular economy applications. Yeah, finally, I would like to draw your attention to two use cases from German industry. Using Industry 4.0 as an example, it will be illustrated how the industry can create digital twins with DPP. How the PCF, the product carbon footprint, can be verified along the supply chain, and how a DPP will also be a driver for the industry. You are probably familiar with the German Industry 4.0 smart factory system. Industry 4.0 refers to the intelligent networking of machines and processes in industry using information and communication technology. The DPP 4.0 enables manufacturers to create digital twins of products with all the necessary information embedded. And you can enter the virtual world of Industry 4.0 via the QR code. And finally, the digital product passport 4.0 and the product carbon footprint. The product carbon footprint, the PCF reporting, will be one of many new regulatory requirements under the ESPR, so mandatory for the European Union. Industry in all sectors will probably be required to provide certain product information in the form of a digital product passport. The showcase PCF at Control Cabinet presents a flexible, efficient and future-proof concept for the technical implementation of a DPP. And you get further information via the QR code. Oops. Oh, sorry. This is the slide for the product carbon footprint. This is from a project from our German Electrical Engineering Association, and it works. The summary. A circular economy is only possible if data on the composition of individual products can be transferred along the supply chain. This requires a digital product passport, which is assigned to the product as a data carrier. Consumers, economic operators, market surveillance, and customs authorities can read the required information from the DPP via a unique identifier attached to the product. Product information is already required by law to demonstrate product compliance with government product requirements and to inform consumers about the nature and intended use of products. The internationally practiced system of quality infrastructure has proven itself for this purpose. In addition to safety requirements, environmental requirements such as a product carbon footprint will be increasingly formulated in the future. DPP will enable the government to review these requirements. In the future, this data will be made available through a DPP system to enable a circular economy. Thank you for your attention.
Thank you, Xue, and thank you for your wonderful presentation, sir. Thank you.
After lunch, I hope my job is to wake people up, right? What we do is we take building material, trash into building material. What we think by doing that, we can actually cut a lot of global carbon footprint and we've been around for a while, and then you can still, I don't know how to move down. Okay, cannot move down. Okay, sorry. I cannot. Oh, okay. Can I move? Just a quick video.
We want to matter.
Of why we do
want
this.
to matter to the non-toxic future of our world. We want to matter to the sustainability of our community. In many ways, it is our mission to change consumer behavior into a circular. It is the only way for us as a species to sustainably consume our limited resources. Overconsumption is a complex system problem. There is no single miracle cure. We want to matter by proving human consumption can be satiated with our very own trash. We have dedicated ourselves to turning decades of environmental pollution into solutions that will enable us to live sustainably. We want to matter, so we turn ourselves into magicians of trash, inventing new ways of transforming our everyday trash into high-performance works of art. We turn milk packaging into the hottest sportswear fashion, plastic bottles into luxurious textile, cigarette butts into furniture and glasses, using fashion and apparel waste into luxurious home furnishings, masks, PPE into cell phone chargers, single-use medical waste material into hospitals, using smart AI technology to make decentralized upcycling possible today.
We head to Taiwan for this report, and a company designing solutions to overcome a mounting problem of a mountain of trash. From furniture to hospital wards, all built from waste, one CEO is on a mission to revolutionize recycling.
His team has used waste to develop over 1,200 different materials for use in construction. The company turning different kinds of waste, like plastic bottles, into materials for buildings and products across the world.
We want to matter, but unfortunately we are out of time. Please join us in upcycling today's local pollution into circular ESG building solutions of the future.
Now you can see lots of applications, and why we focus on building is because building material, it is the highest carbon footprint, and this is one single category that also operates and burns the most carbon. So it's even more than transportation, and we have around 230 million square meters to be built around the world, and that's going to happen around Southeast Asia, Middle East, not so much in Europe, but there's a lot of retrofitting coming up, and that's going to be a lot of EU prerogative to save carbon footprint, and the easiest way for us is to do carbon footprint for building material. Unfortunately, this is a very chaotic market, impossible to get into this market to actually make an influence. So we are trying to merge this business opportunity with this carbon cutting opportunity for the last 20 years. I think just per year, just on Southeast Asia alone, just the green building market is a $556 billion market. And that's why we're invested by the Singapore government, like Temasek, and Alibaba and Taiwan's Fubon Group. So, and we kind of summarize what we do and why only these three things is worth doing. Okay, one is data and software. Digital twins, you heard about that. You heard about passports, digital twins, LCA, carbon footprint analysis. You need to modularize that to make it very simple to fulfill any EU or any, especially now with the scope 1, scope 2, doesn't matter, whatever you look at it, you need to get to a Gabi analysis somehow. And you need to get linked to all kinds of government database. So that's what the first thing we do, to modularize the design process. Okay, so by the way, just if you go to the architects today, you go to a product designer, they don't know how to do any of that. And unfortunately. And number two is that you need to have existing product that already passed all kinds of standardized building tests. ASTM, for example, the EU has its own version, the British has its own version, Singapore has its own version. So you need to get that general test. But one of the advantage about this is that fire hasn't changed, gravity hasn't changed, wind hasn't really changed, the calculation hasn't changed. And these things are all modularized. So we design, you have to have a set of building material that's designed through a digital twin. And how we did that is that we all designed through the Airbus software, the Dassault system. So even buildings are done like an airplane. The other last part is what we are building a lot today. I just came back from Egypt. I also just came back from Abu Dhabi and UAE. We're building factories in Middle East. And so we are consolidating and modularizing these factories. So you're able to take local recycled material into building product. By the way, everyone suspects there's a lot of waste management going on. In the world, I hope you guys know, Taiwan, Germany, Japan is a rare, 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 rare case. Everywhere else, not much waste management. Not even waste management. Okay, you have waste management, then you get material. Then you have a material, you have transformation needed. But actually, Taiwan's lucky because it has a lot of manufacturing. Germany is lucky because it has a lot of manufacturing. But most places doesn't. Italy also. So I'm very happy that I was invited by Taiwan and EU because I guess my wife is part of that EU system. So I guess, yeah, but we work in Italy quite a lot. And of course, the system is actually very chaotic. So now it's how to use these super simple modularized things. And we target real estate life cycle with developers. And this is the only thing that I think that can scale. It's not through working in architecture or working in construction or working in contracting, because those you work with the local contractors, you use those capabilities as modularized to, and especially the machine to expand its impact. So this is just a quick one. We just did this factories in Neom City in one of the biggest construction sites in the world in Saudi Arabia at the moment. And basically, we are taking the trash from all the European engineers who's living there and working there, and that is turning into a new set of building products for the buildings there, building activities there. This is just next door. It's in Shongyan Creative Park. It's next to our office. Basically, it's a baby lab. We have around 4 of these around the world. There's one in Bangkok. Basically, on site, you can actually reproduce, upcycle trash material using a forging process. Forging process is dumb as crap. It's just literally putting pressure, like a compressor. And you can press into almost anything. With an AI camera in the front, we want to demonstrate to everyone who's interested in circular economy that it's not about a long linear process. It's about the decentralization with data and with new technology. And that you can do this very quickly without water footprint, without air pollution footprint. So it has an air sensor that links to every part of a room, so you know that there's no VOC that's being emitted, there's no water footprint. And of course, previously we built a lot of these factories, e-waste recycling plant, big university campuses, and these big buildings give us volume of material we can play. So that's why we can have, I can order 50 tons of something, 20 tons of something in a different specification. So we had to develop that material database, around 2,000 material database in the last 20 years. So with all these different material. And if you go to EU, Paris, London, Milan, the fancy Nike lab around the world, New York, they are all built by us already. And then if you go to the electronic cigarette company across Italy, the ICOS gallery, Milan, Roma, Torino, Firenze, they are all made from cigarette butts. We recycle from Switzerland. We have a cigarette butt recycling process with the electronic cigarette. We take the cellular acetate, we made it back into a modular air purifying brick across these major galleries in these city centers. So they're all still there. And then of course, these type of processes also can turn into building material that apply in a more conventional sense. Office spaces in Tokyo, New York, and of course that you just kind of see that. Fashion waste is one of a big thing that fabric waste, fashion waste, that's from the fashion industry. We started in the high fashion industry. By the way, most of these high fashion industries get burned in Singapore, not dumped in South America, because they need to burn it. It's a controlled burn. So I'm just saying, there's a lot of stuff that we're not actually seeing. There's a lot of things that's actually going on. So we try to take those material and some of a fashion brand's concern and directly turn that into something that's very applicable. So we ship the machine. That's the last one we did. Is recently. It's basically we're building COVID hospitals using the trash. During that time, we couldn't import any EU and Japanese, USA-based medical material, so we kind of develop our own within 6 months. In 4 months, we kind of built a COVID center. Actually saved some lives, and with Vivian here, sitting here with the Taiwan Design Institute Research Institute. So I think this is a funny one, and you think can it be scaled? Yes, it can be scaled, and we are scaling the second hospital now, maybe the third coming up. And they are actually all made from recycled aluminum, locally sourced, locally extruded, and then locally coated, and on top, all the plastic joint you see, they're actually Lego block. They're plastic joint you see, they're actually PE and PP, sorry. And they're actually mainly from a medical waste collector, from a waste medical. And of course, just I briefly show you the image of those projects, just how much carbon footprint that saved. 24,000 tons. That's not a lot, just these projects. We did, because everything we do is with an LCA analysis. So everything's in weight. So I can directly calculate how much carbon footprint we done very quickly, live. But we think that's not enough. Well, we need to do a lot more of this. So we're scaling factories, decentralized local factories. We have built a lot of factories around the world already. And we are trying to do that more. So we have 3 scales. One is a baby scale. We pack everything into a small size that can fold into an airplane. This is designed literally for an airplane door. And then you have the bigger size. It's designed for shipping containers. And then the shipping container combined. And then you have a bigger one. So this is what we're building in Middle East at the moment. We were going to build one in Singapore, but then the COVID hits. So we try to close the loop within the industry. For example, to find the cleanest waste is the most important. The cleanest waste, just so this is a secret review after 20 years. Airport, shopping mall, hotels. Because the waste are already sorted, it's super clean. So you don't even need waste management. So the collector already collected. So how do you close that loop and that become a carbon credit generators? And so that's exactly what we're doing right now. And so that's what these factories looking like. It both have this is what we are designing for Milan. So with the Comune of Milano. And that you can just a 2,000 square meter plant. Just the replacement of existing building material that's substituting, it can do 3,000 tons a year, just on that tiny repo. And so right away, from that same production process, I just want to show you the product. This is National Taiwan University, hotels, shopping malls, bank headquarters. This is just launched. It's a King's Pavilion for one of the biggest chemical company in Thailand, PTTGC. Again, more hospital in St. Paul. And just a quick preview of how we do this digital twin and all the project we do. Right? So it's all digitalized, linked to Germany, linked to different environmental websites, so I can know the carbon footprint right away. And then you can do comparisons right away. This is all instant, live, right? So, and then right away you can calculate its impact. It's very similar to the digital passport, right? But it's much more, and this is Singapore, we recently just finished. So this is just ship the machine first, use the local waste, and turn it into a zero waste restaurants. And how much carbon footprint that saved. And this is far the glory. This is here. This is a corporate headquarters for the biggest construction company here in Taiwan, using construction waste. And then what's the carbon footprint? All right, I will stop at this one. This is the latest that we're doing with Hong Kong. This is a whole shopping mall, and you can see all that orange-ish material is actually made from fashion waste and recycled polyester fiber, antibacterial, fire-rated, cell-insulated, and that with working with European designers like Stoneheader, and it's Norwegian, but we work with Zaha, Ram, famous architects basically around Europe, and they come up with a color. We come up with a technical solution to be able to deploy that in a very scalable way. This is one of the biggest shopping malls that's launching. And of course, we recently, I think Taiwan government has a huge mandate. By the way, I know like Miss Lai is here in the ministry. I just have to applaud Taiwan for stopping the single use at this track with many of a night market. Now no more single use. Okay, that's one. So stop it at the source. The other one is there's government legislation. I want to show this power. It's like Taiwan Power recently, we won a tender, a major tender for green development. And this tender, government issued a decree with a new green building law that require recycled material. So this is a huge. That's why we can win the tender, and that's why now you see all that surfacing, all that interior needs to use recycled material, and that's it. And I think that's the future because now you're taking in huge amount of material, both on the local end and also applying into an actual material, into a building volume. Thank you so much.
All right, thank you. That was from Bigelow, Taiwan Design Research Institute.
I want to thank you. It's my pleasure on the stage and share design how can do for the resource circulation. But I prepared over 15 pages for the presentation. So I asked the organizer, let me steal my Mandarin. And now our audience, you can release your air and just enjoy this presentation. Okay. 那好，我要先在开始之前，我想跟大家分享，因为过去很多人都问我说，为什么设计师总喜欢穿黑色的？所以我今天特别穿了一个白色的衣服。但是呢，黑这件事情在过去其实它不是一种颜色。那在过去的工业发展时代里面，如果也就是说在这个化学药剂发展之前，我们所有设计、艺术、工艺要采用颜色，它必须从大自然或是动植物的这个颜色里面去萃取出来。那在过往，在欧洲，如果你看到他用大量的蓝色，代表这个人或者这个组织或这个皇室，他非常的有权利，那他的财务非常的好。为什么？它是一种表彰这个他自己的权力地位。它就像我们在东方，我们用黄色或紫色来代表自己的这个权力地位的原因，是因为它的萃取过程非常的困难。那所以在过往大部分的设计，大家都会想到都是为了就是贵族而设计。但是在工业时代发生之后呢，我们也发现，其实如果要创造就是更大的经济效益，它不能只为了贵族设计。所以在工业革命，厂商开始非常快速的去追求，我要销量最大，我要产能最大，我要我的使用者可以不断的扩散。那当然，这也造成了很严重的一个危机。这个危机呢，是我们不曾想过，即使在过去的20年前，我们也没有想过，到今天我们会面临什么样的未来。好，那这一个推波助澜呢，是跟我们的 behavior 有关系，就是我们的消费习惯。因为便利，让我们很快速、很轻易的可以去采用或采买各种不同我们喜欢的这个物品。那这也会造成一个困难点，也就是我们的土地是有限的，我所有的这个废弃物，我没有足够的空间去消化它，那我们只能用燃烧。那在过去疫情的期间，我们很开心看到我们的地球就是超载日它往后停了一点点，可是，在疫情就是减缓之后，现在的这个疫情超载日又开始加速了。在今年，如果依照这个 footprint 的 report 来看，它将会是在今年的7月21号，也代表着我们在今年年中我们就已经消耗了这所有的这个资源，地球的资源。那不用到2030年，我们可能都会超淡我们的地球。好，那到底设计能够做什么？其实设计它无所不在，你身上穿的衣服是服装设计，织品设计， 我们所在的这个空间，它有建筑设计跟室内设计。我们所用的每天所用的产品 ，cell phone 好，然后电脑它是产品设计。所以，如果我们的设计能够从源头开始，也就是说，如果我从源头就开始减量，那我们不是只是在思考，单纯思考就减碳这件事情，而是回到如何去改变真正的行为。这个行为它不是只是消费者的这个决策行为，它也包括了采购的行为。那到底我们能够怎么做，然后来达到我们的这个系统？那如果依照联合国的这个报告指出哈，设计在源头，如果我们做得好，可以降低80%我们对环境的负面的影响。那在未来，就是所有跨界的伙伴或是跨界的这个技术的整合，它会需要透过这个方式来去做推进。但是我们也了解，在座的所有的企业，你不可能想要降低消费者的采购欲望，因为它会造成经济成长的这个我们讲说停止。那我要如何去 keep 就是这个经济发展的成长，可是我又能够对我的环境有一定正面的这个影响，设计能不能是其中的一个解方？那如果从这张图来看，其实当设计所有的物件拆解之后，我们可以很清楚的知道我们用了哪些材料，我用了多少的 parts， 这些 parts 它会决定我后续的制成的模式跟我消耗能源的模式。所以如果一个好的设计，它一定势必在后面的这个发展当中扮演一个很重要的角色，也就是我们一直在强调的，就是源头的设计。那一个源头设计，它对于永续的经济体系跟循环的经济体系，它扮演什么样的这个地位呢？为什么我们台湾在这边有机会或是有能力可以倡议说我们要去做这件事情？有一个很重要的，我们台湾的土地面积虽然小，我们的人口虽然也不是世界最多的，这个是好消息，但是我们在所有的产业发展的经济体里面，我们有很多隐形冠军跟很多的 number one。同刚刚 Arthur 有提到，台湾虽然有很多中小企业，跟意大利跟德国一样，可是如果在这个全球的产业供应链里面，我们扮演了这么重要的角色，是不是也代表着我们有机会去可以改变，就是目前产业发展的现况跟未来？那不论是这个大家很熟悉的脚踏车也好，或者是运动休闲的这个游艇关键零组件也好，或是航太或是电子零件，那台湾设计研究院身为国家级的设计单位，当然我们责无旁贷，我们必须一开始就来跟这个产业跟设计师来去做一个推动。那我们是在2015年看到了联合国的 SDG 政策之后，我们开始从4个面向来去跟产业去做对话，包括了我们的设计师们。那第一个其实很重要，就是在于观念的改变。观念这件事情其实它是最难的，但是它也是最重要的。所以我们透过了展览，我们透过了不同的工作坊，我们透过了参访的标杆企业来去告诉大家，做这件事情它能够为你带来什么样的价值。好，可是面对未来，我们要去改变现在这群人的脑袋，其实他要花的时间可能会很长。要改变一个组织，他过往所做的决策模式，可能也会需要耗尽更多的时间。所以我们不放弃，我们另外再择辟了一条路，就是开始教育我们新一代的设计师。我们希望他能够对未来的永续跟未来的这个我们讲说世界的发展扮演一个很重要的角色。那我们也期望我们能够把循环设计或是永续设计作为一个倡议跟使命，作为一种社会革命的运动，就像工业跟过往的艺术复兴一样来去做推动。好，那所以呢，我们在我们自己的新一代设计展里面，我们开始告诉所有的学生们，你们必须在做设计的时候，你们去思考它的这个整个ecosystem 会是什么。那当然，同步我们也不断的就是持续的，就是 keep watch 所有新的科技的解放如何应用在设计上面。所以我们也跟小智研发推了一个就是 material 的这个 database。好，那为什么要去做这件事情？是因为我们的设计横跨了就是不同的领域，所以不同的这个recycle 的 material， 它能够被用在不同的这个我们讲说创造的 solution 上面。其实设计师呢，他必须要了解它的物性。如果他不了解这个材料的物性，或者它的制成的这个限制条件，那很有可能他就没有办法得到最好的这个效果。回到我们的就是 那个 circular 的这个 system 当中。那此外呢，我们也将我们的这个循环设计的这个guideline呢，去导入在我们的产业，透过政府的辅导资源来协助台湾的中小企业或是大型的企业去做发展。最后，我们将我们的成果去做一个相对应的 promote。好，那接下来我就要跟大家分享，其实在今年新一代设计展，上个礼拜才刚结束。我非常感动，因为呢，我们从2015年推circular design 到现在，已经差不多有5-6年以上了。那我本来预期会花很久的时间，但是我在今年的新一代设计展面看到，有超过就是30 piece 以上的这个作品。它都会带到了这个未来跟永续。那其中有2个我非常感动，所以要分享给大家。第一个是最难回收的安全帽，过完的安全帽是属于复合材料的材质，所以设计师这个年轻的设计新秀，他开始思考，我如何能够让这个安全帽可以进入到循环的系统 closed loop 当中。好，那我要用什么样的材料跟什么样的模组化的设计来解构它？那第2个部分是在于就是过往也是很复杂，它的零组件非常多的这个轮椅，那我如何透过一个好的适用性跟回到人的这个使用的本质来去解构它，降低就是生产的这个零组件。第3个是学生们也开始应用新的就是材料，科技材料，包括菌种。去建构就是可回收的这个菌木家具，那它所用的木材也是用再制回收的这个我们讲说家具的这个板料，再进入到这个生产的制成当中，甚至在于对于我们讲说面对新时代的这个我们物流的采购的情况下，我如何能够降低包材？那所以在设计的观点，如何 reduce waste 或是就是降低这个我们讲说废弃材料，让它变成一个资源的这件事情，不论是从制造方，从这个我们的设计创意端来看也好，或者是我们的这个消费者，甚至我们的回收商，它都没有办法各自独立完成，它是需要大家手牵手一起来促成。那在这上面是不是有些设计的guideline能够来协助大家去做这件事情呢？所以我用了就是 fashion design， 因为的产业例子，就时尚的这个产业例子来去做这个说明。如果我们从在各个环节的不同的阶段，我们导入了就是循环设计的概念，它或许就会创造出不同的商业模式跟这个设计的使用的这个解方。那以这个北欧的这个例子来讲哈，本来就是生产一条牛仔裤，它所耗用的水资源，它所耗用的染料，其实非常的可观。可是能不能透过我不要只是不断的卖牛仔裤，而是我可以帮我的 user 去 repair 这个牛仔裤，让他对我的这个品牌产生忠诚。其实这件事情它反而是打破了我们过往一直想要追求量大的这个思维。所以这个品牌商呢，他在2019年，他的就是 repair、reuse、reduce 的做法呢，其实已经创造了，就是帮这个节省了，就是大概5万吨。5万吨的这个我们讲说这个使用这个纺织的这个量。那到了当然它刚刚受了疫情的期间有点影响，可是呢，我们在今年观察到它有很快的在回到就是这个发展当中，一个正向的发展当中。那另外一个部分就是，因为我们都知道快时尚它所造成的这个废弃物非常的庞大，所以能不能将在纺织界里面的这个产业废弃物，或者是民间使用的这个纺织面料，或者因为它本身就是一个复合材料，它不是 single material use， 所以它很难去做这个回用。那我们能不能用其他的方式进入到其他的不同产业领域里面，来提升它的价值，然后创造它是一个延长它的这个生命使用周期。所以我们的设计伙伴们在我们的计划下面开始去思考，然后也创造了就是包装的购物袋，或者是回收的这个羽绒，它可以变成眼罩，或者是再制的商品。甚至我们也跟小智研发合作，将这个产业废弃的面料呢，成为一个办公隔间的一个新的应用。那因为再加上了一些科技，比如说可可粉的这种抑菌的这个材料，所以它就更适合在后疫情的时候去做多元化的使用。 那甚至它也可以变成这各种不同的家具。那除了台湾是纺织时尚的大国之外，另外还有一个部分是我们也是电子很重要的一个关键零组件的这个国家跟供应商。那在供应链里面呢，我们也很开心看到，其实今天应该才能让死的，就是 Logistics 逻辑跟美国的 iFixit。就是去做一个合作，做什么合作呢？大家都知道，滑鼠你如果坏掉了，你会不会把它回收？很少。可是里面它有多少 parts？ 其实它超过大概20-30个 parts。那如何延长它的使用生命周期？这时候这个设计师他就必须要思考到如何模组化，跟我如何可以有效的这个让产品在后续的系统当中是个好回用跟好回收的。所以他们跟 iFace 呢做了一个这个合作，然后甚至去专门去开发维修滑鼠的 tool 让消费者呢他可以自己去维修他的滑鼠，或是到各个不同的 substation 里面去做这个服务那甚至在 Logic 它这边呢也将就是这个拆解的这个服务呢，提供在网站上面，让大家来可以去做回用。那另外一个部分是，我能不能就是用其他的家电废弃材料、塑料来成为我电子产品的主要的来源？可以，所以我们在过去的时间里面，我们邀请核心电子将这个产业废弃物呢、电子废弃物、家电废弃物去做相对应的应用。那不论是在光宝或是华硕，他们也在2017年过后呢，也开始导入了相对应的这个海废塑料的这个再应用，所以我们相信在面对未来有越来越多电子产品，他们会使用 recycled material， 那也呼应了就是欧洲相关的这些法规。那当这个设计它进入到工具机里面，这时候我们就是为了要创造要透过设计的思维去让机材的效能能够最大化。然后也要加速它相对应的这个我们讲说节能减碳的这个效果。那如果是属于农业废弃物，它进入到包材，它可能就会创造另外一种不同的生命力。那我们也期望就是设计师他可以去创造各种不同的符合未来永续的 lifestyle 的产品比如说像洗发精，它可能如果你设计的好，其实它照理讲应该会更节水，更节省就是洗涤的时间。那所有相关的这个民生的用品，如果它都能够呼应，就是用 recycled material 或是 long lifestyle 的这个设计手法，它将能够为我们就是永续的风格里面去创造一种不同的这个使用模式。如果它进到商业空间，这时候它的用量就更大了，它不是只是单纯单一的产品所以我们跟家乐福、跟春池玻璃、跟这个富裕旅店，其实都做了不同的方案。那如果它用在就是废弃建筑废弃物最大的这个量体里面，我们能不能就产生新的解法，改变过去的这个营造的模式？这就是我们跟小智研发在过往我们在思考的。那这是一种系统性的这个设计思维的改变那因为营建业跟病房其他大概在过去200年里面，其实都没有就是大幅度的这个创新。那也因为这个8仙城堡的关系，让我在思考这个案子的时候，其实是在疫情之前是在就是2019年的年中，那医院来找我们，他本来只是要做个全民病房，但是我希望他能够去呼应我们无法未知的这个社会跟使用的这个现象。那我们透过模组化的原理，让它可以就是用回收的材料去快速的建构一个可以在不同的地方。不同的功能，那多元的复合的去做运用，那甚至也改变了就是卫生所的这个模式。那还有大家可能很熟悉的 Ecological。好，那如果它运用在更多方的我们讲说公共建设里面，其实设计它更能够去打造一个韧性的城镇。好，那这是我们在跟这个水利署共同合作打造云林湖尾的这个模式。好，那最后我想用点时间就是做一个结尾。我们都希望我们的产业能够发展高价值、低碳的这个材料，但是要怎么做？3R、5R、7R，其实大家都很熟悉。可是最重要的是，我会希望在座的所有的企业，你要先重新 define 你自己的问题，然后redesign 你的这个策略手法，最后去创造一个 resistant 新的这个产业结构，然后去创造新的这个价值。那唯有我们 所有的人重新建构我们的采购跟消费行为，还有制造的行为，那才能够有一个未来永续的这个地球。那我的分享到此，谢谢。
Thank you very much to Vivian Wu.
Good afternoon, everyone. Thanks for staying with us. Let me switch to Chinese today. I think most of the majority of our audience are from local. So let me switch to Chinese and Mandarin. Was that okay? 所以大家午安，非常谢谢今天主办单位的邀请。那我想今天非常高兴看到有这么多人关心循环经济这件事情，那也非常谢谢黄博士这边给我们这个机会来跟大家分享戴尔在过去循环经济上面的一些成就，跟我们是怎么样去思考循环经济这件事情。那过去3年其实在疫情这个期间，虽然是一个很 challenging 的几年，但是我们没有停下我们的脚步，我们不断在进步。我相信长期有在追踪我们戴尔的，大概都知道戴尔科技，我们每一年每一段时间都会推出不一样的这个创新，不管是材料、服务，还有我们的产品。所以我想，今天主要想要跟大家介绍一下，我们怎么样用循环经济去创造我们的永续价值，好，达到我们永续企业永续的一个策略目标。那在讲这个永续之前呢，我想很重要的，先大家看一下这个数据。其实不管是 CEO 他们认为，未来的 RFP 会一定都必须要去看他们的 vendor， 好，所有的这个永续的一些指标，好，不管是有83%的这个 IT 的产业，他们都认为未来在采购的时候 ，sustainability 永续这件事情是绝对会考虑的。好，这所有的数据其实都在告诉我们这件事情越来越重要，特别是在现在从企业的角度来看，永续这件事情已经变成最 top 的一个 agenda。好，那再加上刚刚我想德国的朋友曾经有讲到那个数位的产品的这个 passport， 好，但是他刚刚没有讲到的是，他刚刚有小小的提了一下一个所谓 ESPR。这个是在达到这个数位的 DPP 之前，其实欧盟即将会在未来的2年去 develop 一个法规，一个 framework 来规定所有的产品，你必须要把所有的 eco design， 所有的 recycled material， 你要使用多少 recycled material， 你的 carbon footprint 通通都要达到，而且最后才是这个 digital 的 reporting。好，所以这个大家可以看到，这个是没有办法避免的一个趋势。那在这个回到戴尔这个地方来讲，我们常常讲戴尔，我们的戴尔人好像这个 sustainability 在我们的 DNA 里面。你去问每一个戴尔人不管是前端在业务的这个同事，或是后端这个做 design 啊，做 R&D 或者是采购以及行销的这些团队，每一个人都非常清楚我们2050年之前要做什么，2030年的永续目标是什么。那不管是对于要tackle， 就是我们要去解决我们现在所谓的大家常常讲的这个气候或是近邻的这个问题或者是说去解决我们现在所有这个产品上面这些所产生的这些废弃物也好等等的这些问题，我想这其中最重要的就是循环经济，其实一个它后面最重要的一个驱动力那过去呢，我想对我来讲，其实我们从1997年最早，我们就开始在全球建立我们的所谓的回收体系，帮我们的客户，帮一般的消费者做免费的回收。好，所以从90年代开始，其实我们很早就把这个所谓的永续、所谓的循环经济的这样的一个实践的理念放在我们的策略里面。那在2007年的时候，我们的创办人 Michael Dell 曾经公开宣称说 ，Dell 要成为全世界最 greenest、最环保的 IT 公司。这是一个非常大的雄心壮志，而且还是公开的告诉大家。所以其实现在想想 ，Michael Dell 他非常有远见，他那个时候就认为，他就看到这个永续其实是一个企业的长期的、长远的一个愿景。所以那个时候他就把永续这件事情放在我们的商业的策略目标。 换句话说，永续这件事情，企业要达到永续，把环境的永续，把企业的永续，这些东西其实都应该要放在你整个企业经营的 component 里面。好，这是非常重要的。那从2010年之后呢，我们因为已经在前面的10几年建制了非常好的基础，所以2010年之后呢，我们开始有非常多的这个创新产生。我们特别是在材料上面的创新，我们用非常多各种不同的recycle 的这些可回收或是可以再生的一些材料运用在我们的产品里面。我们同时也是全世界第一个开始做 closed loop 这个回收塑胶在我们产品里面的公司。那更重要的是，我们没有停下我们的脚步，而且我们所有的这些成果都不是只是为了一个 project 或是一个小部分的产品，我们都是从小部分的产品开始，但是慢慢的去使用到我们所有的产品线。所以我们现在不只是最早的 AIO 那一台，到现在已经大概有100多个产品的 model 都是使用 closed loop 的。那过去几年呢，我们持续不断的推动我们这个所谓的材料的创新，待会儿在下面我会跟大家再做比较详细的介绍。好，那这个我们在2050年，我们其实戴尔有2个很重要的这个永续的策略跟目标。那第一个当然就是所谓的净零，2050年我们会达到 Scope 1跟 1、2、3会达到2050年会净零。那另外一个就是我们刚刚讲的，在净零，你要去推动净零，达到净零这个目标，后面其实是很重要一个，特别是产品面，你必须要有用循环经济、循环的这样子的一个实践的方式才能够达到。所以在循环经济上面，我们其实针对我们的产品、针对我们的服务，我们也设定了在2030年有一个很重要的一个 Moonshot Goal。这3个就是一个是在2030年之前，就是我们的消费者、我们的客户每买一个产品，我们就要有对等回收或是再使用同样的一个产品。好，那第2个就是在产品上面，我们要50%的产品都使用可回收、可再生的材料。那最后是我们的包材，好，包装 packaging 其实一个很重要。那包材的材料，我们要达到100%使用再生跟可回收的这个物质。好，那 Net Zero 这个 Goal， 当然我们会有每一年有不同的这个阶段性的目标。那其中大家其实可以看到 ，Scope 3通常是最 challenging， 特别对于我们 ID 产业来讲，因为它是牵涉到我们整个供应链，必须要去符合。所以上游的部分、供应链的部分，我们要跟我们供应链一起 partner 去达到这个不管是阶段性的目标，跟最后这个 Scope 3的能够完全能够达到这个净零。那另外一个 Scope 3还有另外一个 Category 11，就是你产品出售之后这个使用的这个部分的碳排。这个其实后面又是讲到我们其实很重要，你还是要用一个循环经济的方法、循环经济的实践方式去促成、去加速你能够解决这个部分的问题。好，所以这是我们怎么样去利用我们加速、我们推动循环经济的这个方式呢，在我们的设计上，在我们材料的使用上，去达到不仅是2030年我们自己的 Moonshot Goal。到2050年的净零也必须要仰赖这个很重要的推动力。那首先，我想在设计上面，第二我们一直是有一个很重要的，就是你在整体上你要用一个很系统的方式去看这个产品的生命周期，我们叫 life cycle 的这个 approach， 就是你在 design 的开始，你就要去思考这个产品我要怎么样在它整个生命周期里面每一个阶段都要尽量的让这个资源不要被浪费。让你资源能够被使用到最佳化，那尽量去减少它产生的这个没有效率或是废物的部分。好，所以从design到最后，这个产品不能使用了，那我要 recycle 的时候，还要可以看看它这个产品里面的废弃下来这边不能使用的这个物质，我是不是能够再让它真正去把它 close 最后一里路，让它回到我们的产品里面。所以其实是秉持这样子的概念去设计我们的产品。那至于我们讲设计的部分，其实在所谓循环设计，就是符合循环经济这样子的一个概念的设计，其实它有几个重要的原则。 一个就是你在 design 的时候，你一定要去思考它是不是很容易维修，是不是很容易能够组装。我们能不能让一个消费者他能够很容易的，就是在重复使用，或是他之后这个生命周期到了最后的时候，他在 recycle 的时候也能够很容易 recycle。这个都是在牵扯在 design 的时候你就要去思考的。那再来就是你的维修的部分，消费者或是我们维修的人员，他是不是很轻松、很简单的就能够去把你的东西维修？那这个设计其实就是牵扯到我们所谓的模组化，你怎么样用更模组的方式去设计你的产品？好，那再来当然就是物质的使用，我们能不能使用更多、更有效率、更能够回收，或是更符合资源利用的这样子的一个物質在我們的產品裡面。那最後當然還有就是你在設計的時候，怎麼樣讓它的長久、持久度、耐久性能夠提升。好，那接下來我想要給大家介紹的是一個我們這個concept Luna。那這個部分是其實是一個概念，我們2年前提出的一個概念，就是說到底我們最終我們想到一個所謂最環保的一個產品，一個 PC， 它應該是符合什麼樣的一個概念？所以我想接下來給大家簡單看一下這個非常快的一個短片。好，所以这个是我们它不是一个产品，它是一个成型的概念。那这里面很多的设计概念其实已经 implement 在我们现有的产品里面。那这样的设计概念下来，我们可以大概达到 50%， 就是50% 的这个carbon footprint 的一个减少。同时，它的这个速度，就是你在维修的速度，大概可以快16倍。我们最快的那个 engineer 是花了32秒钟把电脑拆解才回去。所以这个是一个从design上面去思考它模组化的概念。那另外一个很重要的就是，我们其实戴尔一直在业界引以为傲的，也是领先这个所有的 IT 产业里面，其实就是我们在环保材质上面的一个创新。大家可以看到，我们从塑胶、从 carbon fiber 就是这个碳纤维以及一些金属上面的 recycle， 我们怎么把它应用到我们的产品里面。所以给大家简单的看一下，其实这个是我们用所谓的制程上面，就是水力发电的这样子一个铝的制程，去产生所制造这个铝来用在我们的产品上面，所以它的 carbon footprint， 它的整个 environmental 的 impact 是会减少的。好，再来就是我们有铜 recycle 铜的 copper， 这个我们已经最新应用在我们的这个 power adapter 里面。那再来就是在海废的部分呢，其实大家看到，我们最早是只有放在我们这个 tray 里面，我们的包装就是 notebook 的 tray 里面。但是后来我们慢慢从技术上面去慢慢的更新，慢慢的演进。我们现在不光是外包装，我们的产品里面的这个风扇的塑胶壳也可以使用海废的塑胶。那其次还有一个就是我们所谓的 carbon fiber 碳纤维。这是一个非常好所谓异业合作的一个例子。我们是用航太产业跟他们合作，因为大家知道航太产业的这个他们在制造的过程里面会有很多这种废弃的 carbon fiber 碳纤维，所以他们的废物就变成我们的资源，使用在我们主流的这个机种里面。那最后一个是我们这2年一个创新，就是所谓生质的塑胶。生质塑胶我们是用松油，松油是一个在造纸过程里面的一个副产品。那我们用它去提炼跟石化塑胶一样的这个特性的塑胶，用在我们的产品的外壳上面。好，所以其实大家可以看到，这个是我们现在目前主流5000系列的这个大概是目前最环保的这个产品。我们大概有 大概有64%的这个 recycled material 在里面，我们所有的员工都在用。我今天带来的那个 notebook 也是一样。好，所以这个是在材料上面。那包装上面，我们同样也有我们现在所有的这个100% recycle 的 laptop， 就是我们笔电的包装已经改成这样子了。所以包括你可以看不到，你在里面是看不到塑胶袋的。好，那另外还有一种是我们减量的部分，我们有这种所谓 multi-pack 的 solution。好，那我们的客户对这个理念非常的强。好，那这样子也是减少客户使用的空间跟节省客户的时间跟他们使用的空间。那最后一点，我另外要讲的是一个很重要的是 business model 上面的 change， 这个其实是在循环经里面更重要的一环。我们刚刚今天前面讲的都是产品，怎么样去使用在产品做 recycle， 但其实更进一步更重要，循环经里面更重要的是一个所谓分享 sharing 的 economy。这也就是我们大家常看到所谓以租代买。那我们戴尔也很早就跨出这一步。好，我们对于客户有提供所谓的这个以租代买的这个服务。好，所以客户他就省了他要去处理 IT 产品，要去 maintain IT 产品的这样子的一个。那对于我们来讲，我们也会有一个 motivation， 想要去把我们的产品设计得更持久。好，那所以这个是已经慢慢变成一个产业的一个趋势。那今天我觉得我这边特别要谢谢这个赖处长啊，特别要感谢环保署，我觉得他们迈出了一个非常重要的一步，就是在我们的这个采购法上面开始要去针对我们这个政府采购上面也能够试行这个所谓的以租代买这样子的一个 model。那这个不仅仅是，其实对台湾是非常 challenging， 在全世界，我可以让大家知道，在全世界的这个政府采购都非常 challenging， 要用以租代买，因为他们有政府采购有他们自己一定的 cycle、一定的 budget 的方式，一定的法规，这后面需要花很多的时间。但是我觉得台湾目前是我看到大概全世界首先去跨出这一步的，所以这个我觉得要给我们的环保署一点 credit， 非常感谢。我觉得这一点也是我们引领在全球的一个很重要的。那我想，因为今天时间很短，那没有办法非常详细的大家来讲我们的这个一些，但我想最后用这个非常重要的这个一个简单的一个 summary 的 film 给大家做一个结尾。那我想，循环经济是需要透过大家一起的努力，创新跟协同合作，不光是法规，不光是我们企业，我们的partner， 我们的这个供应商他们也是非常重要的一环。
Change is inevitable. Whether it's for the better depends on what we all do next. That's why we're working to turn the greatest challenge of our time into the greatest opportunity to drive human progress. With the right actions, technology, measurement, partnerships, and people, we will achieve net zero greenhouse gas emissions by 2050. To do this, we're reducing our energy needs while accelerating and advocating for the use of renewable electricity. We're working with our suppliers to help them manage their emissions, and we're continuing to design, build, and test innovative products and business models to reduce emissions. And we'll do it together, harnessing the power of technology to help people, businesses, and society achieve their own climate goals, so that we can face the changes that are to come and embrace new solutions that will transform the future of our planet. Join us.
Thank you. Please join us. 谢谢。
Thank you very much to our 5 speakers for your inspirational speeches. We have seen a lot of innovation and a lot of hope and a lot of execution. Okay, so for this 15 minutes long discussion session, probably I can have this privilege to raise my questions if there is no further questions from the audience. Okay. But if there are, please raise your hand. Okay, okay. I would like to probably propose 3 questions in advance. so that probably each one of you have 3 minutes of responding. Okay. The first question is that I was wondering what are the major challenges that you have encountered during your working or in general regarding circular economy. So what are the major challenges and how you have overcome or suggest to overcome these difficulties? Okay, that's the first. And the second question is that I think it takes time to transform the current linear system into a circular one. Because a lot of elements needs to be incorporated into the transformation. To name a few, we need the policy, regulations, innovations, business strategies, as well as behaviors change, right? So it takes time. So I was wondering what kind of major progress have you observed in your work? Okay. And the third question is regarding what are the major, I'd like to have your opinions, what are the major advice to the government, to the industry, and to the citizens? The matters you think most impactful. Okay, probably we can start from this way, okay, from video.
So we start with the first question, right?
What
are the challenges we've been encountered and how we overcame? I think from our cases with this circular economy journey, I think the most challenging is really, firstly, the communication and how to have your stakeholders to buy in your ideas. Because I think we started very early, around like 15 years ago. So at that time, it's very challenging, very still limited. We don't even have so-called circular economy, this common words that we can share with the same language, talking with the same language. So I think how to communicate it with your stakeholder and ask them to buy in is very important. That stakeholder means your boss, your co-workers, your peers, your supply chain, right? So I think that fortunately, that is also, I think, how Dell came a long way, that our founder, Michael Dell, has really had that vision. And because he had that top-down communication to everyone in this company, so everyone in the company will have the single goal. So we are aware, okay, this is the direction we have to go for. I think it's very important for any company, any corporate to have that goal, that direction, right? And the other part, I think the really challenging is really from the execution part, when we are really working on the so-called closed-loop recycle process, for example, it's always the back and forth from the technically, right? You have to work with your engineer, you have to work with your suppliers, right? Our suppliers actually came up some kind of material for us, recycled material, right, from closed-loop process. Then our engineering will turn back and say, oh no, it's not good enough, right? Because while you want to use the recycled material to tackle this journey, but at the same time you can sacrifice the performance, the safety of the product. I think that's technically still have that challenge, but we did overcome that with our engineer. So I think that's probably the top two cases that I can think of that the challenge over this journey. Yeah, so pass to.
Yeah, thank you. I think that's the core was communication. Communication, and you know, my topic was standardization and regulation, and we have one language in the world for this. This is standardization. So we have all perspectives, different perspectives, but the same goal we achieve. And so I think it's very important to work together and do it in the standardization, do it we don't need single solutions for the European single market, for Asian markets or US market. We need solutions for the whole industry, for the supply chains, each of this. And so this is a challenge, but I think it's a part of the solution to have global standards on the challenges of the circular economy. And the communication, this was one of the arguments here is very important to change the mindset. And this is what we have to do as government, yeah? Not to say, do it, because people do what they want to do. So they have to change their mindset, because it's maybe it's sexy to do it. Yeah? So this may be one of the possibilities to get it.
Thanks very much indeed for that question. I think the starting point here is that government's policy should not strangle businesses. Businesses are quite capable of adapting to their marketplace and to competitive activity. So micromanaging a business from a policy point of view is a negative. When you look at businesses, you've got to segment businesses into large corporates like Dell and go down to the SMEs, and there's a different mindset. So at the large company level, you've got a conflict between short-term priorities and long-term deliveries. So the short-term priority would be for Dell and others, is you've got a 12-month profit target to hit, because your investors, your shareholders will expect a return. If you're looking at an investment for a circular economy model, that's going to take slightly longer, so you've got a risk profile here, and those conflicts sometimes exist. I think one of the important observations I have is you've got to get the board to support the circular economy model. You have a lot of board directors on there that are wedded to the status quo. And in order to progress to a circular economy model, you've got to get the board in line with its agenda, and sometimes you can't. And that's why you get this sort of stalemate. But when you go down to SMEs, they're entrepreneurial by right. So you've got a start-up position with a vision and a determination to get there. Now again, you have another challenge. With a large corporate, you've got the balance sheet to raise finance and funding for it. You can get it through the stock markets, or you can get it through from the funders. But as a start-up company, very, very few financiers will finance an early start model because they see it as perceived risk. So the idea of trying to complement the two, one, get big businesses to take a bit more of a risk in order to preserve their status quo, and at the same time incentivize small business to actually come up with the new models. Because if you imagine a life cycle of a business, it's a start-up, it grows, becomes mature, and then dies at the end. All businesses will follow that model eventually. So what we should be doing is encouraging the next business entrepreneurs to come through to replace the products that are now coming to the end of their useful life. It can be done. I've seen it myself. I've illustrated it in terms of the examples I gave this afternoon. And when you see it in action, when you see large businesses take the risk and small businesses coming through with massive, challenging ideas, you can only take hope for what's going to happen next.
So the first question is, what's the most difficult part? Scalability, I think. I think this is, and initially, and what's one of a scale is what needs for that. For example, to produce a material, if you guys know, you need at least about 5 tons to get one material data. Okay, that's why, for example, for a big corporation like Dell, it's going to be very difficult for them to test 300 different material data, because you need to collect 5 tons. Okay, and then when you produce one batch on a proper run, it's around 27 tons. Just think about it, for any startup, who's going to have that capability to be able to do that? That's why the innovation is very slow on this front, and no one's going to invest in that unless there is already business opportunity. And nobody, I work with Nike, these are very good people, they will not promise you they will take it at the end. Never. Never. Okay, so this is one of the biggest challenges I think throughout our time have. But now, I think one of the advantage in the micro environment is one, is government is actually because enough education is being done. Standardization is becoming very real. Because there is somebody today tell you, oh, let's talk about carbon footprint. Their whole standard is so chaotic. That's not true. That person, if you heard that person, you gotta fire that person right away. You know? It's already standardized by Europeans, ISO 14040, and now there's a tax scheme that goes with that. You cannot go against that. How Tesla make money, that's how they make money. Come on guys, there's already standardized. The calculation is standardized for the last 30 years. Now is, what do you do with that standardization? I think there's a lot of big four consultants are still faking it, a lot, okay? So can we please get out the bullshit in the room and then just focus on what is really, every product should have a carbon footprint analysis, and it's already there in publication. I see a lot of nodding heads, so thank you. I know you guys don't want to say that, but I would say that for the audience in Taiwan. It's standardized. There's nothing is not standardized, okay? So I'm just saying that is very different. And the last thing I want to say is the financial industries and accounting standards are taking hold of that same thing. Okay, using that standardization, they are able to evaluate a company in a different way. This has never been done before, and that's why our business has actually grown tremendously after the COVID. Okay, and now we are actually just going into as almost like a proxy to the government to set up infrastructure. So, and why? Because they see opportunity. They want to implement the standardization, but they don't lack of infrastructure that's required to do it. So they need somebody with enough design, engineering, and data capability to be able to execute it. That's as simple as that. So we get to work with Italian machine supplier, Taiwanese machine supplier, we get to work with data scientists from Holland, Belgium. They were coming together into a platform. And I think that's the future of collaboration, and that's a real collaboration, because people get money from it, right? Otherwise, it's all.
Okay, let's talk about. I think the first is about the mindset change, especially for the small and the medium enterprise, because they will need their supply chains can support them. For example, they need to find out the recycled material, and they don't know where is it, and they also need to use a new machine to use a new recycled material, but nobody do it. So it's just very hard to later check the circular economics achievement. And the second is about the cost. I think there are a lot of people ask why for a green product is so expensive. And that is a big issue we need to face it. And I think let's just also talk about the scale up. Usually when you have more demand, and they can help the manufacturer to cost down, but who will be the first? I think the branding company, just like Dell, should be a pioneer company to lead our supply chain to do it. Yeah, and if for not just for government, I think for all while, if we need to achieve our suspicious goal, SDGs, I think we need to think about how could we redesign the regulation. Yeah, regulation. Because now, this moment, we use the old regulation to face our new issues. It's very tough. If we cannot use find the insights we cannot, how to say it, we foresight the future. How could we promote our industry to use a design solution to achievement our goal? Yeah. And finally, I think everyone will talk about the money resource because our new solution is a very high risk for any enterprise. So we need the government to give them some support, let the bank can more easier to help them to do the green proposal, and then we can have the green future. That's my answer.
Yeah, thank you for sharing your experiences. So I think you have singled out several difficulties like communication, mindset, and also the conflicts between long-term and the short-term objectives, and also scalability. Okay, I think, and also regulatory transformation. I think Taiwan EPA has embarked on the journey of transforming the current systems in terms of several policy and regulations. So, but again, there is a lot of a gap between ideal situation and the realistic situations. But we have indeed witnessed a lot of progress. There are successful cases, but there are also failures. But that's how we transform ourselves, right? Due to time limit, probably we need to close this session. But I would like to say thank you again for your inspiring speech and sharing your insight, and looking forward to us taking this journey together. Okay, thank you.
And I'm Yang Hu from National Taiwan University of Science and Technology. It's my great honor to host all of you to join this discussion. Supposedly, it's the final discussion of this day. So when we have dinner, kind of depending on how we go in this session. Okay. Okay. Special thanks to Mr. Steve Peters, traveling from Manila to Taiwan. Okay, and we appreciate all the attendance here. Okay, I think the topic of this session, resource recirculation, especially concerning about the waste to energy. I think that is a focal task for our next generation. Okay, it's a very tough challenge, and really we need the contributions from all stakeholders, including the government, the corporations, the academia, and all people should join the effort. Okay. However, I think the infrastructure and I think the infrastructure and the tools for resource circulation probably is not so complete. So that's the reason we are discussing here, because we need more effort on this issue. Okay. So in this session, we're gonna have 3 distinguished speakers, and they're gonna give us their contributions on waste to energy. Okay, so shall I introduce Mr. Stephen Peters? I met Mr. Peters during the break, and I told him that I have some very special respect to whoever the last name is Peters. Okay, because my PhD advisor, the last name is Peters. So I saw the Stephen Peters, wow. Okay, so and Mr. Peters have been work with ADB for more than 5 years, right? And he is really special and specialist in this area, because he has been contributing to so many projects. Even before he served in the ADB, he was served in a company in Singapore, which is also dealing with all kind of energy to waste to energy project. Okay, so probably we just welcome Mr. Peters. Okay, a big round.
Thank you. Ladies and gentlemen, please forgive me. My Chinese is very limited, and I will probably say something wrong. So if you don't mind, I'm going to speak in English. So first of all, thank you very much to the EPA for the very kind invitation. It's always nice to be here, and I love the food, and I'm loving the weather. But I haven't stuck my head outside since this morning, so hopefully it's still nice. I'd also like to thank the EU. I've learned a lot from our colleagues from the EU. And I feel very blessed to be presenting today because this is a really, really interesting panel. And we've also got some very interesting people in the audience. So today's presentation is going to be about energy waste and data. So we talk a lot about what's the technology we use. And I'll just check if this is the right button. We talk about what technology we should use. What we don't talk about is why. Why are we using one particular technology or one particular technique? So I'm, funnily enough, going to talk about the Asian context. So everybody's talked about here and the EU. I'm going to talk about everywhere else in Asia. And I've got about 26 years working in Asia. I've been to over 300 landfills, so I know what money smells like. So I'm going to talk a little bit about where I see this decision-making going. And it's going to be talking about how we can simulate waste streams, some of the apps we have, and where I think that the easy yards are to be achieved. So Indonesian government contacted us about 2 years ago and said, we have a problem with our waste and we would like you to tell us what we should do. Should we do this or should we do that? And what we did was we built an object-based model that built off some work that was actually done in Singapore, Ron. The initial work on this was an object-based model done in Singapore. We hired the PhD who did it, who then built a model based on the waste hierarchy and all the particular interactions. And what we figured out was we could game that, we could create a simulation. So if you do one activity, it leads on to another or it drops out. Now this may not look particularly circular. I don't know if that's going to work. This seems to be linear, right? But actually, when you apply this and you capture the data, you can then use it in a circular loop. So this is the beginning of stopping the linear, extractive, take, bake, and I got a new word for today, degenerative. I love that line, degenerative economy. So if you want to have something that's circular, you need to be able to track what you're doing now. So we figured out that there were probably 200 different types of interventions, and I saw the book here today. There was about 40 interventions from black soldier fly to rice husks to SRF, all these sorts of things. So what we decided was there are about 150 parameters that can describe those. It sounds like a lot of data, right? Actually, it's pretty easy. And we figured out if we made a discrete entry for a particular activity, sorry, I'll go back. Discrete, we could describe any activity in the waste supply chain with those 150 parameters. And this is all publicly available information. I can share with you, you can get access to it, you can play with it. And if you want to send us some information about your process to be included in the database, we're very happy to. So the tool's called WARPS, because ADB loves acronyms. We like, a bit like, we like to have an acronym and a nice name. And basically what you do is you identify a location, a particular catchment, then you enter in basic waste parameters. I have 20% plastics, I have 50% organics, of which 65% is moisture, that sort of stuff. Then you go through and you then start simulating it. So I have, if I put in a sorting facility, I know maybe I'll get this much, and I can game, you can game what actually is going to happen. And you are able to modify that if you are sophisticated enough to modify the model. Then what happens is you can set policies. Do I want to have a carbon price? Do I want to have a price on pollution? Do I want to have a plastic bag price? Do I want to have a bottle price? What works, what doesn't? So you then can game that information. Then after that, you can look at the economic parameters. What's the tax rates? You know, what are some of the, do I have funding for capital investment? And then we go through, we can add pricing. So each particular country, the price for plastic recycling, for PPET, all this stuff, different stuff is there. Now, this is very different to most of what we've talked about today, because what we're doing is we're modelling what's there, and EPA's done a fantastic job of doing this already, and in fact, in my view, it's the best system in the world. What we're doing is we're taking some of that thinking to communicate this to policymakers in other countries like Indonesia and funnily enough, in Cambodia. We recently finished an assignment where we talked to the Cambodian government about what they should do, and they asked us to give them some simulations, and then they've decided to move ahead based on the information we have from the simulations. So then you get a summary of what's going on, and that summary can be broken down into particular objects. So an object might, in this case, be an MRF, material recovery facility. So it'll have what's coming into it, what's going out of it, what are the parameters. And then you can roll them up and aggregate the information. So this, and it comes with a Sankey diagram. This is a highly simplified Sankey diagram, but it's just used for explanation. This is the really important part. So what we have here is how much money does the government have to subsidise for a particular activity. And you'll see that there are different types of activities based on scenario 1, scenario 2, or what the activity is. But then, from this data set, you can work out how many new jobs does this have? What are the greenhouse gas emissions based? And it's simulation, it's not exact, it's plus or minus 15%. But for policymakers wanting to make a decision about, should I do a waste to energy plant, or should I do waste to energy with SRF, or should I do waste to energy, say, with biogas, or should I spend more money on recycling? And it's what's important to you is the policymakers can then make the decision what's important. UPOPs, my personal not favourite. Persistent organic pollutants, dreadful things. And the problem with waste to energy is it's a producer of them, as is volcanoes and bushfires. Coming from Australia, I know a lot about bushfires. So if you look at some of these scenarios, they produce more UPOPs. And they produce it in two ways. They produce it in the emissions, even though their emissions meet standard, but they also meet it in the fly ash that they capture. And very commonly what we're finding is that people are not treating that fly ash in a way to lock that material up. That's a really big issue. And in fact, for us, we worry about that because we fund a lot of waste to energy plants. And we are looking at ways to have technology to treat that fly ash in such a way that it gets locked away in a ceramic lattice or in a way that's inoculated for the period of its life. Take that very seriously. I like you nodding. You're totally correct. What's the next one? SOX. But there's more. Wait. We also provide new jobs for women. Which technologies are suited to providing jobs for women? Now, it's very strange for an old fat white guy to start talking about jobs for women. But we take this very, very seriously. Because if we're going to beat climate change and we're going to beat our challenges, doing it with one arm tied behind our back is pretty stupid. So that metric is really, really important. And I think policymakers are only just starting to understand it. Other things like, what's that one? I can't read it. My vision's not very good. Informal workers, looking at PM. And then the bottom one I think is very interesting. We use DALYs, which is a measure of how many years of someone's life they couldn't operate, whether because they died or because they became incapacitated. And we can infer that information based on the data we have. We've got some really interesting results that some technologies actually, from a health point of view, are perhaps not as good as others. So this model has just allowed us to simulate some of the activities we have in waste. And we use it as a decision-making tool, but we also use it as a communications tool with our developing member country partners. Now, that's part of an overall strategy we have to try and figure out how can we get very quick gains and very efficient gains by using digitisation. So although this is a waste to energy session, this is all really about digitisation and the easy wins you can get from digitisation. Here's a great little app from India called ReCity. We ran a competition 2 years ago about what are some of the apps in waste that we can be used to manage waste in developing member countries. And this came from India. What we found is Indonesia and India are hotbeds for these apps. There's lots and lots of these apps. And they looked at Uber and they said, and Grab and some of the other technologies and said, oh, this is pretty smart. Why don't I copy and do it for waste? If you have a look at that, that's in the local language Odisha, in Odisha State, and we did a report on this. Artificial intelligence. Who here has used ChatGPT? Okay, that's interesting. Who here doesn't really get ChatGPT? And it's okay, it's all right. It's okay. Wow, that's interesting. You're the first audience with no hands. Of course, it would be here, right? So AI is going to become ubiquitous. We're already using it when you book an airline flight or when you order a taxi or whether you're having interactions. You just probably don't know it. ADB is setting up a artificial intelligence lab with AWS, Amazon Web Services, and we are looking at ways of changing our business process, but also implementing technologies to accelerate our agenda, which of course is to get people out of poverty, to not do nuclear activities, and to look at fighting climate change in a just way. I'm glad, I can't remember who had just in their transition. I think it was our colleague from Germany talking about just transition. Just transition really talks to not tying one hand behind your back, right? Very, very important stuff. So what's going to happen is we're going to pilot a whole bunch of new and crazy ideas. And this is a bunch of French guys who are in Cambodia said, you know, I can use AI to tell the government where to pick up a piece of rubbish. And we thought, oh, that's a bit cool. And then they showed us how to do it. So they basically built a model. They used AI with optical character recognition, which is was talked about today by one of our other colleagues. This stuff, if you're under 20, 25, this stuff is like opening a can of soft drink. For them, it's intuitive. For older people, it's like, wow, this is rocket science. This is sort of like Star Trek. But it's not. It's here. It's now. And we've got to make use of it. So this is a tuk-tuk. Tuk-tuk driver puts the phone on his car. His vehicle drives around. And then AI says, oh, there's a piece of rubbish here, or there's, someone's dumped a whole bunch of stuff, or whatever. This can also be used for disaster resilience. For instance, someone drives past and a bridge has collapsed. So this type of technology is going to be run-of-the-mill. I had a presentation from a Japanese company last week using exactly this same technology and news feeds to help inform emergency services recovery. So this is all already happening now. The challenge we had with this app was it used a lot of bandwidth, and in Cambodia, bandwidth is not as easy to come by. So the real limiting side of this was digital infrastructure, not digital innovation. So there's some of the images. This is a heat map in Phnom Penh. SPADE is ADB's GIS platform, which is basically the European Space Agency's platform, which we purchased, and then we're putting our development data on it. So what's the next steps? So we're simulating and gaming supply chains. We're looking at performance of supply chains. We're communicating that to government. And this is all stuff that can be done in parallel with everything that's been talked about today, from data passports to the incredible work of MiniWiz, which just, for me, blew me away. Really great, man. Really awesome. So then how do we get this to convergence? How do we get this data and make use of it in a way that we can get insight? Data is useless on itself unless you can get insight from it, right? Absolutely useless. I had someone talk to me last year about insight as a service. I'd never heard that before, right? I think he means he's a wizard. But this technology allows us to integrate enormous amounts of data. And the reason I'm here is because you've got 30 years of transforming what was pretty awful into this, which is just beautiful. You walk down the street here and it's just beautiful. Now, I love the fact that today is all about how, oh, we want to do more, we've got to do better. And I'm sitting there going, okay, well, I don't know if you've gone outside of, you know, to other countries and seen how they are, but they're not very good. So from our point of view, there's a great deal of information that we can use, and there's a great deal of knowledge and learning that we can get from you. And also, not just the panelists, but everybody in the room. So this is an example of a supply chain which was heavily influenced by a meeting I had in 2019 here. Heavily influenced. And according to my research, and I've done a bit and I have a few resources behind me to allow me to do that research, I reiterate, you have the best system in the world. You've got the best system in the world. So how we then capture that information and drive it forward, digitalise it, also add in all of these other amazing things that happen, is being created here now. And the future is here now. It's pretty wild. So on that note, I'm going to finish up, but I'm going to say one thing. I had a meeting in Korea a month ago with a senior ambassador, and he said to me, oh, I was in Central Asia, I won't say which country, and I met with a whole bunch of younger people, and those younger people said, we want to do something, we want to make a difference, and we want to make a difference not by throwing everything at what we've got. We want to decide how can we create a movement that people can get behind. And I just thought it was a beautiful story. They decided on an idea called Me First. I'll go first. I'll be the first person. I'll be the first person to pay more for electricity. I'll be the first person who pays, invests in this fund. I'll be the person who works on this research. I'll be that person. Me first. And what's really interesting about this meeting today is all of you have a Me First story. I applaud you for your Me First story. I'm so glad I can get a chance to talk to you. Let's make the future, and we can do it with digitisation. We have all the tools. Thank you so much.
Thank you, sir. Thank you.
Good afternoon, ladies and gentlemen. My name is Judy Wu, and I'm head of BSG office at Wi-Fi Group. So thank you, EPA, for inviting YY to share some of our experiences. So Me First. So we have a lot of firsts because we are a 100-year-old company. So a lot of things happen while there wasn't a term for circular economy. So Wi-Fi is actually a holding group, a holding company, and paper making is our core business. And then we branch out over the years, like to many other vertical industries, including special materials, technology, biotech, and financial services. So, but the experiences we are sharing today is mostly our circular economy practices in the paper industry. So, the company was established 1924, so it started as a trading company, and we introduced fertilizer for agriculture into Taiwan. So basically, that's how we started, and we'll be celebrating 100 years next year, 2024. And back during the 1930s, cane sugar was actually an important export product in Taiwan. So Wi-Fi, we use the agricultural waste from the sugar cane waste, we call bagasse, to make construction and building materials, and we ship to Japan. So that's how we started that was sort of kind of the first example of a circular economy product. And the left you see here is actually a business license, which was very rare, that's granted by the Japanese occupation period during the period. And by 1950, based on our experience with the agricultural waste, bagasse, so we started using bagasse to produce high-quality typing paper because trading with international countries was very popular at the time. So we started producing typing papers, and that's how we started our journey of paper making. So over the years, if you grew up in Taiwan, you will probably, in your lives, you'll be familiar with one or a lot of our products. We produce all kinds of paper products, from textbooks to old magazines, publications, and the first stamp, and the first doc, and also wine labels. And until recently, we produce a lot of specialty materials, specialty papers. So if you grew up in Taiwan, and I think YFY participate a lot or involve a lot in the culture and the education development of Taiwan's economic growth. So over that past few decades, we have established 5 cycles of circular economy through our paper making process. That includes paper cycle, water cycle, agriculture cycle, renewable energy cycle, and carbon cycle. So we often say that Dale was saying circular economy was their DNA, and for us, it's also a business philosophy and DNA as well. So over these 5 cycles, it's actually one connect to another. So our topic today is biomass renewable energy, but actually it's coming from water cycle and also paper cycle. Without that, we cannot produce new energy. That's what we will discuss later. Around 10 years ago, 2013, in China, we used agricultural waste to produce pure natural pulp. So we call it unpulp. Why it happens in China? Because in Taiwan, the agricultural farms are all scattered around. It's hard to collect large scale, again, scalability. So it's hard to do that in Taiwan. So back 10 years ago, we do it in China. We collect all the agricultural waste to make a pure natural pulp. And that was quite an achievement that time because the farmers thought, wow, the waste can produce economic value as well. But the point is the pure biological process to producing the natural pulp actually was recognized by a lot of customers. I think Dell was one of our customers as well back then. So we're using green packaging for a lot of the consumers and enterprise customers who value green packaging as a way to go. And also Unpop won us Edison Award back in 2014 for its achievement in sustainability innovation. And fast forward to 2019, it's our biogas power generation. So if you know paper making, water is a very important medium in paper making. So it's usually 1% of fiber with 99% of water. So how we reuse and recycle the water is very important. And also wastewater treatment is also very important as well. So at YFY, our technology or what we are proud of is our anaerobic digestion technology. So we have very strong and powerful anaerobic bacteria that can turn the organic matters quickly and turn it into biogas. And we then turn the biogas into heat and electricity. So currently our largest biogas power generation in Xinwu plant is 5,200 kilowatts. And the fermentation time is around 4 hours, which is pretty impressive if you compare to international benchmarks. And the purity of our methane is up to 83%, which is also a great data here to show. And another way is how we do paper recycle. So in our paper packaging business, 工业用纸, we actually use 97% of recycled paper. But within those recycled paper, there's a lot of unusable materials such as plastics, tapes, or labels. So we collect all those waste, and because they are all like good waste as fuels, so we turn it into SRF So we are probably one of the first SRF installations in Taiwan. And we turn the waste to energy, and currently the largest Xinwu plant SRF power generation is 9,500 kilowatts. And with that, we can reduce 87,000 tons of coal every year. So that's something we are very proud of as well. And that is Hualien. Hualien is the only place in Taiwan that currently produces pulp. So right now, there are a lot of paper plants, but there's only one pulp plant in Taiwan. And you need wood chips to make pulp, right? So some of the wood chips, 50% is cellulose. Cellulose goes to making the pulp, and the other half is lignin. Lignin is actually a good material for biomass energy. It's a good raw material. So back in 1968, we already operate that biomass energy in Taiwan. So we always say it's the earliest and it's the largest because it's the only one. And it's the biomass energy with lignin in Taiwan. So the above three case studies, SRF and biogas and this lignin, our biomass energy is all coming from our 5 cycles of circular economy. That's why our topic today is for energy, waste to energy. And this is our recent project. We are working with Taoyuan city government. They have a Guishan 水资源回收中心, Guishan water recycling center. We are using our anaerobic digestion technology and know-how and experiences to help them to turn this 30-year-old wastewater center into a green energy center. So, 龟山它处理很多这个工业废水、住宅废水。So with wastewater from residents, commercial establishment and industries. So we are recycling their water and turn it to biogas and turn it to energy. That's the current project we are working on with Taoyuan city government. And with that, this is my last page. So based on our experiences, know-how in that, we established a business group late last year, Carbon Tech Business Group, because we are seeing there are 2 directions going, smart energy and circular economy. So basically, we are leveraging all we do and what we are doing to leverage that to help others, to work with other industries. So we focus on renewable energy, which is mostly biomass, and we also focus on energy storage. We are hoping to build decentralized energy grid. And so in Taiwan, you probably can imagine there will be regional smart energy hubs instead of a centralized big Taipower. And the other direction we are going is the waste to energy circular technology. So including the green energy I was talking earlier, and also we are open to collaboration with public facilities and city governments to help them transfer all the waste into energy. So that's pretty much my presentation today. Thank you.
All right, thank you. Please give you 他的技术提升过，老师长。
各位贵宾大家好，那接下来我会比较准确的表达一下我的意见所以我就用中文来跟大家做说明。那我今天想要跟大家，因为刚刚前面2位讲者都有多少提到 SRF 嘛那我常常最近常常有人打电话来跟我讲说，就是我们最近推得很成功 ，SRF 的议题很夯但是这边我就来跟大家说明一下，这件事情其实不见得我们推动每一个这个废弃物转能源化的这些策略或是我们各种物料的循环，其实它是有它的限制那所以尤其是从废弃物去转制成资源或是能源的时候，因为它的来源是废弃物，所以在管理管制上其实要特别小心所以我今天在我的简报的内容里面我会有很多关于我们在管理的办法上面来做说明当然会先说明一下我们过去这几年跟环保署跟我们工业局这边合作有一些成效，推动有一些成效首先，我们台湾基本上跟其他世界国家接近那我们在处理废弃物的时候，最早是从卫生掩埋，其实也不是从卫生掩埋，从露天弃置、卫生掩埋，再转化到我们的焚化，跟我们的接下来就是讲我们的更进一步的废弃物的能源与资源化 那其实废转能呢，在过去上就是 waste to energy， 大部分人都会用来形容，其实就是焚化这一块那其实焚化对于我们来讲呢，其实它的能源效率相对是比较低，但是它是一个一劳永逸可以把废弃物彻底的安定化解决的问题而且它对于这些废弃物的处理它的相对的处理的弹性是比较广泛的那当然我们其实换另外一个角度，我们在后面的我的简报里面会说明到，我们现在把废弃物里面的一些适合作为燃料的这些废弃物高热值的废弃物，把它提取出来以后做成燃料，它可以利用在更广泛、更高能源效率的这个锅炉里面，那能够有更高的发电效率、更高的这个效能其实高的效能就代表更好的减碳效率所以其实但是我们需要注意的一点其实废弃物是有限所以我们今天在讲所有东西的循环的时候，我们必须要先想到一点，就是我们以台湾为例，我们去年烧了4400万吨的煤炭，但是我们很多人在主张，很多公司在主张，它要用 SRF， 用废弃物燃料或是用生质燃料来取代煤炭。那我们看一下全世界最大宗的这个固体生质燃料木颗粒加棕榈的最大的产量加起来，再加木片料7000万吨，两个台湾都不够。那另外呢 ，SRF 我们就算把所有的这个我们过去这26座这个焚化炉每年烧大概这个600万多到700万吨的这个垃圾，那它的相对热值也比较低所以它能够取代掉4400万吨煤炭所以我们必须要这样讲所有的替代燃料没有完美的，没有又便宜又干净又好烧的东西，污染排放量要低的所以每一种燃料都有它的局限性，即便是像今天我们用废弃物做燃料，它都有它的相对应的局限性。那其实我们可以看这一张图在欧盟国家这边其实很多国家跳过中间的焚化炉，就直接进到下一个阶段废弃物的能源资源化，就是废弃物的燃料化。那跳到废弃物燃料化这一段呢，其实我们可以看废弃物燃料化，我们可以用一张很漂亮的结构，一张流程图来做一个说明我们把所有可以烧的废弃物进到这个经过收集清运以后，进到一个燃料化的工厂以后，做出来的东西，可以当燃料的跟不可以当燃料，把它分离出来。不可以当燃料的，如果还是可燃物，我们送到焚化炉去烧；如果可以当燃料的，那我们送到工业用锅炉，或是像这些水泥窑这些热处理设施去使用。那这个看似完美的这一张的这个结构图其实它里面有非常多的不平衡。比如说今天水泥窑它要的是什么？它要做的是产品。今天我们所有燃料混进去里面烧以后，它其实会产生出来的灰烬全部混在它的水泥产品里面。所以当你今天的燃料的性质是有所差异，是不是那么理想的时候，其实这会大幅影响到它使用这样燃料的意愿，因为会影响到它的成品。所以当我们今天想要让这一张我们讲这个废弃物能源化的图越完美的话，其实我们在各式不同的地方要做让步。因为这个图画起来好像是100%平衡的，但是其实有很多，比如说像我们100%全烧，我个人也会认为说我们在烧这些替代燃料的时候，大家都喜欢主张 RE100， 喜欢烧100%全烧的炉子，也喜欢100%全烧 SRF 的炉子，可是其实这不见得是一个最好的选择，因为当你烧出来的灰，像以德国为例，全烧 SRF 的灰渣其实大部分都还是盐因为性质上差异太大，不好处理所以有些弹性的做法，比如说像我们使用混烧使用混烧来做这个煤炭的参配一半的时候，其实对于它的燃烧稳定性跟它的空污排放的表现，另外就是与它的灰渣再利用，其实有更棒的一些优势那废弃物的能源化其实它包含了2项，包含我们早期所说的这个焚化那焚化它的缺点就是它的能源效率比较低，因为焚化的目的是在于安定化处理掉废弃物，不管好烧不好烧，可燃物占比高或低，我的目的就是要把它减基安定化，所以能源回收只是它顺带。那如果我们今天是走到燃料化，那我们只会提取其中适合作为锅炉燃料使用的这一部分，所以能源效率是它追求的。能源效率是它追求，但是当你想要追求能源效率的时候，对不起，你的炉子要用的比较好，你对燃料的你能选出来的东西，能源效率要越高，那我们能够选出来的这些废弃物其实越有局限性。所以其实做废弃物能源化没有绝对的好或坏。那也有很多焚化炉业者，当我们在这个提说我们要做废弃物燃料化的时候，他们认为是一个竞争对手，其实不是，这2条线是相辅相成的。就过往来讲，甚至应该这么讲我们焚化炉的设计热值单位设计热值不会太高。那 也不会因为我们今天垃圾的热值高了后，我就要把热值拉高。其实我们焚化炉目的是涵盖更多的这个废弃物进去啊。其实我们包含今年这个桃园新上线那个生质能中心啊，龙井的生质能中心，我们从1984年开始，我们陆陆续续盖了我先漏掉，不要讲那个盖了没有运作，我们有运作的26座这个大型的以生活垃圾为主的这个焚化炉它每年大概烧掉了650万吨的垃圾。那另外呢，我们可以提供很充足的这个电力，但是它的能源效率是低的，平均我们的这个发电效率大概只有20%。那台湾因为我们地处亚热带地方所以我们在能源的利用上面其实不像欧洲国家或是像日本、韩国那么的，连低温的热水它都可以拿来再利用。再加上我们传统的观念，我们认为焚化炉就是一个闲物设施嘛所以希望它赶得越远越好那这一点其实我就以身作则我买了不是买2栋房子我买了以后再搬家其实我第一个在木栅焚化厂旁边现在我是在新店焚化炉旁边所以其实在焚化炉旁边，老实说烟囱很高那才是最安全的地方，越靠近它越安全了如果真的有问题的话，但是焚化炉毕竟就像我们刚刚讲，我们先不要讨论它老旧，或者说它因为到了操作年限的问题而是我们要从废弃物的处理转型来看，我们要走到下一个阶段的时候，废弃物燃料化就必须要在这个时候能够做多一点的努力所以对我们来讲，做废弃物燃料化，其实它的目的是在增加能源的效率。其实，在能源的效率上，这增加更多的弹性，尽可能的去减少生产更多的替代燃料，减少化石燃料的使用。这个是它的最大的原则所以我们大概在2019年这个书里面就已经开始公告了一些相关的这些废弃物燃料化的这些政策跟措施嘛那是不是这2019年才开始呢？其实我们在更早之前就酝酿了很久。能源局在大概2000年左右的时候就已经有推动协助各家职厂推动这个废纸排渣去做这个 SRF 所以刚刚永丰余的那个经理也介绍过了朱莉也介绍过，其实永丰余、正隆纸业，我们这几家大型的职场就是我们做这个废弃物燃料化的先驱。那 SRF 到底是什么东西不是所有可以烧，这边有个观念不是所有可以烧的东西都可以拿来当做 SRF 因为这个东西有可能你今天看起来好烧，可是它能烧，可是我们跟总反应的表面积有关系，厚实的塑胶、高热值的塑胶，或是像 PVC， 它的不管是性质、形状、形态，我们必须要能够让现有的做成燃料，让现有的工业用锅炉可以使用所以 SRF 它其实最重要的第一个来源是它的原物料来源是来自于废弃物里面是不可这个自然性的非有害的废弃物。第一个是要非有害，因为我们这样做出来的燃料是散布到各个工业用锅炉去使用所以在管理管制上，我们不能把风险做分散，有害的东西或者是不适合作为燃料的东西或有风险使用的东西，我们就把它送到焚化炉去使用那 SRF 它其实就是从我们经过多次回收以后剩余没有回收价值或者回收价值比较低的那这些物料里面我们来做成我们的替代燃料。那这里面可能它就不会是单一性质，所以 SRF 相对于我们讲的非木材或者是像我们的生质燃料木颗粒、棕榈壳来讲，它的化学组成上或是它的成分组成上是不稳定的那我们不能够期待，比如说有一家 SRF 制造厂，其实它是一个中间再利用机构，那它每天它就有50家产源，可是它不是每天固定给你固定的量、固定的比例，它的废弃物来的是有时候有，有时候没有所以SRF 的品质不稳定是它本来的特性那其实这些可以借由管理管制上面我们可以去做到一些妥善的调试可以去克服这样的问题。所以 SRF 呢，第二个就是早期大家有听过我们台湾有 RDF 嘛，那 RDF 呢大概就只能粒状，可是 SRF 的话，其实我们可以做什么？可以做成依照工业用锅炉做成各式的形状。那所以其实我们自从2019年开始以后推动以后，其实我们到了去年2022年我们大概每年已经有产出20万吨的 SRF。那这20万吨的 SRF 基本上可以取代将近15万吨的煤炭。另外呢，它可以减少大概13万吨的温室气体排放。那换作是因为它使在更高能源效率的工业锅炉、气电工程锅炉，其实它相对于我们原来在焚化炉里面只有20% 的发电效率来讲，其实它在能源上是占尽了优势那这一张图就是可以告诉大家我们现在现况那包含我这边蓝色的点是我们现在大型的焚化厂，就是我们旧式的这个废弃物能源化的这些场所那第二个就是说，像我们的红色的点就是我们 SRF 的炉子，跟我们这个绿色的点就是使用者其实大家可以看见，大部分的 SRF 的制造厂这些废弃物燃料化工厂还是集中在西半部 那用户的话，其实也是在西半部。那比较特殊的哈，就是我们大概有几个大型的这个水泥啊，在花莲跟苏澳，它的用量非常大，但是问题是它距离我们所有的废弃物产源都比较远哈，这是它的劣势。那废弃物能源化，由这张图表我们可以看到，从大概2011年开始做统计到今年的3月哈，我们其实在这个国家统计我们再生能源废弃物能哈，废弃物能就是这个粉红色这一块啊，它的占比是不断的在消减。那它的占比在消减，其实它的这个发电量是没有变化。其实主要是因为我们其他的再生能源有所提升了哈。那为什么没有变化？其实还是反映到我们刚刚讲的那个问题，其实废弃物它的量是有限的哈。那接下来我们可以看一下我们国家对于这个未来推动这个 SRF 它有一些政策。第一个就是我们在这个再生能源政策里面，就是我们要这个展绿，然后那个是叫什么？就是增加天然气的使用啊，那减少我们的煤炭的使用，跟我们这个达到无煤哈。但是其实我们到2025年，我们缺乏60亿度的绿电哈。所以这些替代燃料，不管生质燃料或者 SRF， 只要你有减碳效益，在应用上面其实是值得我们推动跟推广的哈。那我们除了中央的法规规范以外，其实我们各县市它都有各自的自治条例啦，希望减少煤炭的使用。其实这一点的压力对于业者来讲，是比中央的政府政策还要来得重的哈。但是这些老实说，我们在看待各个县市在推动这些无煤化的过程中，其实它是有一些可以站在更专业的方式啊去协助业者去做转型的，而不是说就以最好的例子来讲，新北市在推动无煤的过程中，其实有非常多的我们比较中小型的这些燃煤的锅炉啊，就纺织业就倒闭了哈。那但是其实这边有一点哈，就是我们推动废弃物的能源化哈，那利用趸购 FIT 制啊，就是我们的趸购费率来讲，它目前的这个费率是3.948啊，老实说其实还是偏低啦。那如果今天这样子产业真的要能够赚钱的话，它必须要是一条龙的从前端收废弃物到发电，其实才会适用哈。那未来我们都会建议说，如果要推动，其实政府应该要更为的这个积极啊，去提供更多的奖励跟补助了哈。那接下来我们在管理管制上来讲啊 ，SRF 其实它的管理管制其实非常简单，它其实做出来这个燃料是我们大家唯一一次有机会把一个废弃物重新组成大家要的燃料。那最重要的这一点就是大家要的燃料，所以我们其实 SRF 的分选厂，不管是设备好，或是你收的废弃物好，收的废弃物，其实要依据后面使用者的需求。如果今天它的这个处理费再高价，你做出来的东西没人要，它还是废弃物。而且当你今天把它转型以后，它会是一个更难处理的废弃物。所以这边可以看到，我们其实在这是原来的欧盟的 EN15359哈，现在是ISO 把废止掉那个 EN15359，统一由ISO 21640哈，对于这个 SRF 的这个管理管制啊，我好像前面废话讲太多了，不好意思。那其实真正的 SRF 到底是做什么？就是我们把混合的废弃物啊，利用分选的方式去分离出我们所要适合做燃料的物质。那其实，在法规的规范，尤其现在的厂商大部分都喜欢用最低成本的投资啊，去处理最贵的废弃物，那就是事业废弃物。所以大家在设备的投资上都会非常的精简哈。但是，所以我们为了避免这样，其实我们看了其他国家的一些经验，我们在法规的规范上，其实针对必须要有的设备啊，其实都有做一些律定的哈。那另外一个就是 SRF， 它大概适用的锅炉，老实说非常多种，但是我认为目前国际上最成熟，那我们台湾应用最好，大概就2个，一个是流体化炕式的锅炉，一个就是我们的那个，不好意思，流体化炕式的锅炉，另外一个就是我们的这个水泥窑，好，但是也不是所有的流体化炕式的锅炉都可以使用，其实它还是原来设计烧煤炭，那你再烧这些其他种类完全不同替代燃料，其实它有很大的差异哈。那再过来就是我们使用的这个燃烧的方式有混烧跟全燃烧哈。那其实我个人还是比较偏好混烧，因为混烧其实对于锅炉跟燃烧利用设施来讲，我们讲一年过去只有20万吨的这些 SRF， 可是你今天买不到 SRF 的时候，如果你的锅炉压宝就是要压全烧，你收不到的时候，对不起，这个炉子就是跑不起来。所以混烧其实是针对产业来讲哈，我们兼顾到经济可行性跟产业运作的弹性的一个最好的方式。另外，其实它的混烧灰渣的性质哈，跟再利用方式哈，还有就是它的那个空气污染排放哈，跟燃烧的控制会比较理想哈，会比较理想。那环保署今年针对我们这些废弃物跟我们的生质燃料，好，它提了一个方案，这现在目前还是草案，就是有分成3类，这个叫资源循环燃料。第一类就是纯的生质能，好 ，Type 1。第二类的话， 不好意思啊。第二类的话就是我们的 SIF， 第三类是没有任何规范管理管制啊。这一点其实我们还有很多物料的性质是不错的，像废轮胎跟这个废木材，可是它其实并没有像我们 SIF 定了那么多的管理管制的方式啊，所以其实它会落在第三类。那就我的认知啊，那这个是市场目前供需的状态哈。就是说，我们现在市场各个锅炉的许可量将近50万吨可以使用 SIF， 但是就去年到去年年底，大家收到多少？只有收到36%，只有收到36%。那这个问题并不是说大家不喜欢用，或者是我们的 SIF 制造厂不够。另外有一张图表可以跟大家讲，就是我们的各个 SIF 制造厂的它的许可量是将近90万吨的可是它收到废弃物都不到20%，也就是那真正说明是什么？其实我们没有那么多废弃物，那有没有需要那么多的发电厂？有没有需要那么多的那个SIF 制造？可能大家要好好思考一下因为当你今天讲说我一年要烧10万吨、20万吨、30万吨的 SIF 的时候，到底我们全台湾有没有办法供应这些东西？这个才是真正的逻辑那这个是我们现在目前遇到的问题。第一个，因为现在环保署我们还是比较积极在推动事业废弃物做 SIF 那但是我们找不到合适的 SIF。接下来今年20万吨，我个人预估SIF 一个国家的这些替代燃料的这个废弃物做替代燃料，跟它的人口数是正相关的。那所以我们用日本来做推估，它的 RPF 产量150万吨，人口是我们的5倍。其实我们 RPF 跟 SIF 就是相近的东西，大概一年就是30万吨左右。目前到了20万吨，加上今年我们经济发展其实是迟缓的所以其实废弃物量也不足，所以接下来从20万跑到30万，我想是会缓步的提升那没有办法做爆炸性的成长。那我们的解决方案有什么？当然其他国家一年有破50万吨、60万吨、70万吨 SIF， 必须会有生活垃圾进来。一般的家户垃圾，但因为又臭又脏又湿不好分，所以它的投资跟它的这个技术跟我们一般做事业废弃是完全不一样，再加上它的处理费比较低，这一点其实是一个蛮大的挑战这一个蛮大的挑战。所以它有在欧盟大概就是用 MBT 的方式是用最低的成本、最合理的方式去做所以这个我们还在一部分还需要去努力那接下来我再多花一点时间跟大家讲一下它的环境效益。当然 SIF 它的不是只有减碳效益，我必须要老实跟大家讲 ，SIF 也好，生质燃料也好，其实是我们在推动物质的再次循环、资源化，以它的再次循环为目的，减碳不是它最优先的目的，减碳都是它的附加效益。减碳都是它附加效益。我们不是为了减碳去使用生质燃料，我们其实是因为它堆在那边烂滞，所以我们拿来当做燃料。那所以使用 SIF 一样的道理我们使用 SIF 可以把原先弃置不用的、难以处理的，或是我们要到更低的、比较低效能的这些焚化设施，如果我可以把它精简化，拿到这些锅炉来使用纯化拿到锅炉来使用它其实会有更好的表现那这边我可以跟大家讲一下，减碳效益呢虽然是附加，但是我们可以看一下，大家可以看到这边有一个2氧化碳的排放系数这是我们协会跟废管处这边每年大家都会对于各家厂的这个燃料做一些分析那其实根据它的废弃物的来源的组成不同，其实它的碳排放系数会不等的有一些厂它以废纸混合物为大宗其实它的碳排放量大概就是煤炭30%，但有一些像纸厂他们在回收废塑料、回收废纸的时候，它的排渣出来就几乎因为纸纤维都会回收了所以其实像它的这个碳排放量会跟煤炭接近，因为它都很纯的是塑胶所以其实这些都是有方法去做预估的所以用 SIF 它是有效能的，但是我们也不能因为这个 SIF 的碳排放系数的高低来去否决它使用的优先顺序，因为每一种燃料、每一个废弃物，其实我们要算是假设它今天走到焚化炉去的时候，或是任意弃置的时候，它对于环境的影响所以我们在看待这些替代燃料的时候，其实要思维上是要比较开放一点我们不是为了减碳为目的，我们是要看的其他的环境效益那所以其实当 SIF 它是从废弃物来的时候，其实它的管理管制上本就应该要更为严格那我相信这几年的在这个环保署的努力之下，其实我们对于这些厂的管理管制其实是看得出来是可以上轨道的尤其对它的品保品管，尤其像今年开始针对这些 SIF 厂有一些品保品管的规划其实更有助于我们在推动废弃物燃料化更往未来去发展那以上是我的简报，谢谢各位。
Okay, we just heard other contributions from three speakers, and I realized that for resource recovery, no matter that is waste to energy or whatever, some other techniques, we really need the involvement of all stakeholders, government policy and corporations, and also some academia research organizations. And what I'm thinking is for Stephen, okay? Yeah, because you mentioned that you have been actively involved in those kind of activity in mostly Southeast countries, right? But I think that the WAP, the tours, is very interesting to me. And but I think because the development in different countries is so huge different, and also even in one country, the different areas, the development is also greatly different. How can you promote those kind of tours, or well, even probably sometimes it's not so easy to implement those kind of tours because of the tour itself. It looks like very comprehensive, but when you try to implement the data, okay, the data is very localized and they're very hard to collect. Okay, so do you have any experience or difficulty you would like to share with us?
Yeah, I think I'll take that out of my hand. One of the challenges is getting decision makers to be on board. And those decision makers are not only government. I was really impressed with your presentation about how you guys went first. And there, in many countries, there are organisations that will take the lead and they will make action. And I think what happens is that you have to go first sometimes, and those people are the ones that we then need to lionise and promote. But then you have countries where you can't get someone to go first, and government, there is a market failure. And we have another tool that we're working on, which is looking at simulating investment opportunities for provincial and municipal governments. And it's copied from some work that was done in Spain about 15 years ago in Madrid. And what we say to governments is, okay, if you, say for instance, you have a parking system in your country and you decide, I'm going to put parking meters, well, that gives you an opportunity to generate revenue. And when you generate revenue, then you have something that you have a balance sheet against. And so as a consequence, many of the governments we work with, especially at local government level, don't think like businesses and cannot attract finance. So it's going hand in hand in, I want to be fundable, I want to have a business that is regenerative, I want to have a city that is clean. But that first step either requires a line or it requires an intervention. And so we sort of have to do both.
Oh.
That's the answer.
Okay, so if a government tries to propose a proposal, or they try to get some funding by ADB, so you're going to run the what for evaluation?
Well, we're doing that in 2 countries right now.
Oh, really?
So 2 countries came to us and said, we don't know what to do. And in one of those countries, it was that there were 5 separate departments that had an involvement in this space, and they couldn't agree.
Okay.
And so this tool was used to help them get some form of consensus.
Okay.
So it's really more of a marketing and engagement tool. It's not telling people what to do, it's showing people possibilities and then letting them agree and do it their way.
Okay, great. So it's basically a supplementary tool, not a very decisive tool for that.
No, it's not a design tool. So okay. you can't use it to design something. What you can do is that you can use it to inform policymakers.
Okay.
Yeah.
Okay. So, okay. So, because Mr. Peters and all previous speakers talking about digitalization of the resource recovery, what do you think about? Can that be implemented in your country? How to digitalization, how to modernization? Yeah, because sometimes in Taiwan we thought we are very pioneer in modernization, in digitalization. But when I heard of the speakers, the foreign speakers, they are very concerned about how to digitalization. of the resource recovery system. What do you think about if we try to adopt those kind of concepts in your company? Okay.
Yeah, good question. So we are a 100-year-old company again. So digital things, probably not too familiar with the older generations, but I think right now the younger generations, they are really embracing that. So we are trying to implement something starting from how do we reduce waste, enhance efficiency, and so that they will be welcoming these new tools instead of against it. So we are implementing Six Sigma and other manufacturing efficiency methodologies to improve that, so with digital tools. So I guess next year maybe our presentation will be done in ChatGPT. So we are also introducing a lot of courses how to make ChatGPT your co-pilot, your co-worker. So we actually have training courses, online training courses for all the people in the factories. So we are trying to, like, all kind of mindsets to help them embracing, because we're more traditional, we are not like semiconductors where digital thing is a common thing. So in our industry, digitalization is something that you need to transform them to do that. So right now we are using that for manufacturing efficiency and energy efficiency. And also we are using AI to monitor the accuracy of paper, because paper is a long roll. So if there's a defect in this long roll, you have to stop the production. And it's gonna cost a lot because you stop the machine. So you cannot stop the production. So we are using AI to detect the very small defects. So make sure the notebook we are using, the papers are pure white, no defection. So we are trying to, every angle possible, to implement that digital technology in our process.
Okay, thank you. So Dr. Zhang, you are more focused on the biomass, right? Biomass, and it sounds like it's more difficult to try to do a digitalization on that system. Okay, because in the industrial West, I think Taiwan established not so bad, probably we could say good tracking system. Okay, but for agricultural West, the biomass is really difficult, very difficult. So do you have any ideas about how can we digitalization or modernization of that part? In that case, because you mentioned that the utilization of biomass in Taiwan using the ratio is quite low. We have a great space to expand. So what do you think about in that part?
First of all, I have to explain the SRF, and this is the waste fuel, and another one is biomass. So this is totally different. The biomass is without the plastic, without the fossil material. But for the database, we know the woody biomass. We know the rice strong, wheat strong. Those are different biomass. We know their characteristic. We already have the data. So, for example, like a wood pellet or like a PKS, this kind of a fuel, we know the property very well. So we can just modify how this kind of fuel apply in different kind of oil. So it's easy. So, but for the, I think more difficult things is like a SRF, because it's very complicated. So from the project, we cooperate with EPA. We have some project every year. We will analyze the raw waste characteristic. So actually, I find some how to say that? I find some 它有一些特性different plastics or different waste, like maybe your papers, like we recycle paper, like YFY, they have a recycled paper and reduce and produce a lot of SRF, but most of them is waste plastic. So we know what is their heating value. We know their oxygen content, carbon content, so nitrogen content. We have this kind of data. But for digital things, because I think we need more data to contribute the database.
So Steve, do you have any suggestion for how to implement, how to digitalize?
He's nailed it. No, he's nailed it. He knows exactly what's going on. I'll take that on later again. That you do, when we looked at this tool, making SRF is one thing, and then using it is another. So, for instance, in Pakistan, outside of Lahore, there's an enormous number of factories that use plastic from Karachi, and they burn it in boilers, and it's terrible. And it is an enormous health hazard. And so, any way that you can get some of the biomass that is causing all of that pollution in other parts of India and Pakistan to be used in the boiler is very helpful. But then what do you do with this plastic? And then, so then the question is, do we, as ADB, do we go on a program to promote investment in boilers that have gas cleanup or operate in a way that can handle heavily plastic materials? And where you have a slightly different problem is that you're not doing it from plastics only, you're doing it from industrial processes. So you might have cadmium, you might have zinc, lead. I was really interested in your statistics that you had. That makes it very difficult to decide, do we have a grade of SRF which is acceptable in a particular type of technology? And that then creates a bit of complexity.
Okay.
And I think that's a bit of hard work, but I'm sure you can solve it.
Okay, so for Ms. Liu again, so I'd like to realize that your company has been contributing for 100 years, basically for the biomass resource recovery, right? So is the company ever considered to serve a more active role for resource recovery? Probably from a paper company become some kind of resource recovery company, because you have recovered the biomass basically from the water, from the paper and pulp. But that is some similar to some of the biomass we have. So do you have any ideas that the company can try to make some movement to move towards the resource recovery industry?
True. So we didn't start out say, okay, we want to do circular economy. We started out because we want to solve our own problems.
Yes.
So we have wastewater problems. That's why we have biogas. And we have recycling waste problems, a lot of plastics. So we have SRF. So now we are seeing what kind of problems or solutions that can map to the problems we have. So currently, during the paper making process, because the raw materials contain a lot of organic materials, so a lot of organic things that different kind of elements. So we're trying to make it with, consider maybe it can be a good fertilizers for agriculture, which is, actually we're experimenting that. So fertilizer for agriculture. So that's kind of a waste to resources. And also we are thinking of construction materials where a solid waste can maybe turn it into building materials like 砖头, like 砖头, 建筑材料, the construction materials. So basically we are not going out say we will be a resource company, but instead we are solving problems, our own problems. And then we are solving other industries' problems, and then we come up solutions. That basically our idea.
Okay, thank you. Because the time is up. So I really appreciate, we really like to express my appreciation to the honorable guests for their contribution. And also, I also like to offer congratulations to Taiwan EPA for great leadership on this conference. And I hope you all have a great achievement, and also we have a great learning from this conference, and probably we should give a big hand for ourselves. Okay, thank you.